participants. Good evening, one and all. I welcome you all to our day 4 session of Tableau DataViz Challenge 2021. We have our trainer, Mr. Mohan, with us for the day. So he will be taking the entire session for the 3 hours. Over to you, Mr. Mohan.
Yeah, good evening, one and all. Hope all of you are doing fine and had some great learnings yesterday with Team SmartBridge. Last couple of days with Mr. Shivam and team. Hope all of you had some glimpses of the wonderful journey on Tableau DataViz Challenge 2K21. Got some awareness regarding your Tableau visualization, what is visual analytics, how to start with as a beginner, what are the key functionalities that this tool actually brings to you. With all the basic knowledge regarding the utilization of tool, right from launching it, installation, launching, to the elements of Tableau, right, the data pane, the canvas, till the types of visualizations, how each visualization really appeals. I hope all of you had a wonderful journey, and all of you also witnessed the visual grandeur of the dashboards with Tableau. Welcome, boys and girls, ladies and gentlemen, on day 4 on this journey with Tableau DataViz Challenge. Let me present my screen with you all. Participants, can you all see my presentation?
Yes, sir.
Right, thank you.
Yes, Mr. Mo. Your screen is visible now.
Welcome to day 4, hands-on with Tableau. This is the agenda for the today's evening. We'll start with a very quick glimpse at chart types, which was already dealt greatly, and was a lot of insights were given by the expert yesterday. But still, it is a very important aspect for every member in the audience to understand why, as a visual researcher, why should one understand the selection of suitable chart type or a visual tool whenever you are planning to present your data into a visual presentation. After a quick understanding of the chart types for a visual presentation, then we will focus our insights on the industrial case study. The first one being from the banking industry today, that is analysis of term deposit buyers for retail banking. In the project, I'll be briefing on with the overview of what is retail banking industry and a research problem statement that we are going to learn and solve it. We'll also address the objectives and the challenges and a typical business scenario and how to resolve it. Then we'll then start focusing on building very good solid business intelligence dashboards and story points. Dashboard, a glimpse was already given yesterday, a hands-on demonstration. Hope all participants also had a quick experience with how to build a dashboard in Tableau. We'll also focus on attention on the device designer, how to customize the created dashboards, how they actually appear on different hardware devices. Then we also shift our attention on focusing on how to create a story, a visual story point in Tableau. Once a detailed hands-on session on the case study 1 is completed, then I have planned a practice case study for all our participants to gain more experience, practical experience on how to utilize visual applications in industrial segment. The practice case study comes from the energy management sector, that is the power sector, where the case study focuses on performance analysis of combined cycle power plant. I'll be briefing the overview, objective and the data set and leaving the activity to the entire audience for you to enjoy the fun with Tableau. This is followed by Q&A session. Hope all the data sets for today's activity have been shared to all the participants. Please keep them ready whenever I just hint you all. Here we go on a fly. Welcome everyone to the journey. While for a data analyst or a visual enthusiast planning to learn a lot of things from data, the typical prerequisite to begin is start your learning, your implementation activity, building your visual talent by understanding the right chart types. Typically, if you ask any data analyst, who's a researcher or industry guy or as a practitioner of data, We segregate the practice of data analysis and visualization modeling, especially with visualizations, into four major areas: comparison, distribution of data, composition, and learning relationships patterns among data. While each of these major categories are equipped with specialized set of visual tools in any operational IT software, be it Microsoft Excel or SAS or Tableau or any other kind of typical application, one must have an in-depth understanding of what visualization has to be used for what kind of visual representation. To start with, the first one, usually most of the world's data that we usually deal will be a continuous data or numeric, while a part of the world's data is non-numeric, that is categorical. A typical portion of the data also spans into the text, audio, and video. Hence, this era is the world of big data, dear participants. Whatever is the case, if you just want to go ahead and want to study the comparison between quantities in universe, Tableau provides us with a plethora of visualization tools like what you can see here. On the first part, the comparison category is you can compare among items as a whole or over a period of time. How do you want to compare? So comparison is broadly categorized into among items and over time. In the among items categorization, you can start by initially doing a bivariate visual relationship by picking up two variables per item. I repeat, under the among items category, a data analyst can initially start by performing the statistical bivariate analysis or bivariate visualization, which involves studying the relationship between two variables. A typical suitable chart for this type is the default and widely used column chart for two variable representation. However, in real world, under the data analysis, most often data enthusiasts would be inclined to study the relationships among multiple data items or multiple categories. In such a case, to model a visualization that exploits the relationship among multiple parameters, statistics recommends cross tabulations or tables where you can embed charts. So you can tabulate the characteristic relationships between multiple categories, usually in a tabular format. Apart from this, you can also study a single variable at a time, that is univariate or a bivariate again, using yet another widely recognized visualization scheme called the bar chart. Bar and column almost are used for representing the categorical distributions of data against a measure, while bar can be used to represent huge collection of data, that is many items, whereas in contrast, column chart typically represents a collection of fewer items. So this first part, what you are seeing on my screen is the collection of charts in Tableau, which commonly a visual analyst prefers whenever comparison of data is required. The other part of the comparison participants is time parameter associated visualizations. Whenever we speak about time parameter being found in the data, like your experience in the Superstore dataset yesterday might be, where you all might be worked with expert on order date, month, day, year. These are all the variables or the features or the explanatory variables that are more associated with the description of a scenario, business scenario in relation to time. A typical visualization on demand for most kind of such data can be broken down by time period into two subcategories, namely cyclic and non-cyclic. While cyclic represents the recurrence of an activity over a time, non-cyclic would more or less represent a seasonality or a trend, typically represented by a line chart. Hence, by default, in your research problem statement or in your project, whenever you want to represent data visually that contains time parameter, time bound activity, you can go for a typical line chart for a non-cyclic or a circular area chart for a cyclic representation. But sometimes data which are time bound, like in your Superstore, you have an order date field, participants recollect it. order date encompasses within it three other data components, namely the day, the month, and the year. If you want to break down the analysis, slice and dice or drill down the analysis, and specifically want to study the impact of each component on the outcome, you can again utilize the time slice or the time quantum of the business by picking up a month or a year or a day and project it into visualization using a column chart or a line chart. Yesterday, you all learned about, maybe in the day, on the initial part with Tableau, you have learned how to build hierarchies. The order date was broken down into year, month, day as a hierarchy. Each broken down level of hierarchy typically has certain effect on the outcome of the sales and profits of the superstore. So whether it is a particular time period or it is a fewer periods or a time quantum, still Tableau can compare data properties effectively. So the entire layer on the top portion of the screen attributes visual section of tools which are typically used for comparison. These are not only for Tableau, this appeal to any analytical IT, operational IT software as part of industrial project management or research, academic research. Now, coming to the second most important vertical of visualization, understanding distribution of data. As I quoted a few minutes ago, most of the world's data is numeric, dear participants. If you as an analyst or a researcher wants to understand how the proportion of the data or the distribution of the data is actually spread over under a certain explanatory variable, you can select a single variable of interest under your univariate analysis, or two variables under bivariate, or more than two variables, that is 3 or 4 under multivariate analysis. Typical visualizations available in Tableau that allow you people to understand the distribution of data include histogram, one of the finest and widely used visualization for understanding the spread of the data over a particular interval, class interval, is breaking down the data into typical ranges called statistically the bins, data bins. Whether data is of few data points or spread over multiple volumes, still you can build a frequency histogram, or you can go for a line histogram or a density plot, typically called as a density plot. You can overlap a histogram, frequency histogram, with a density plot to much know in depth about the deviations or this variance in the spread of the data can be best exercised with the combination of histogram with a density plot. But a most important practice in distribution analysis, especially in tool like Tableau, is the need to represent two-dimensional data on a coordinate system space whenever the quantities you are going to compare are continuous data items. Imagine, participants, you are one day planning to study the relationship between price of a product, which is a continuous variable, sale value of the product, which is again a continuous variable. So typically, to model the relationship between two continuous variables, a recommended visualization is the scatter chart. The scatter chart exhibits a mean of association, strength of association, typically the correlation, to speak statistically. That statistical relationship can best be studied between two numerical quantities using a scatter chart. In any research problem, your internship project, or your academic research, or a PhD or postdoc, do not hesitate to use a scatter chart whenever you want to study quantification analysis or the kind of relationship you want to model between two continuous variables. Sometimes, to understand the plethora of research on the complex data patterns among the multitude of variables, Tableau also recommends analysis of distribution or spread between or among three or more variables. Typically, we scale an axis here rather than a two-dimensional coordinate system. We also have the advanced 3D area charts, which are a minimal improvement over the traditional line charts. While line chart projects the representation between two dimensions on X and Y, the area chart typically extends the visualization on the third dimension, that is the Z axis. So one has to be very aware when and where should I use what type of chart, because this is the world's problem where every researcher, every learner is facing initially. Where should I start with? While all graphs appeal in a traditional IT software, one of the typical appealing feature of Tableau is Tableau essentially highlights the recommended suitable charts which appeal for a particular relationship model or a visual representation. So beginners need not worry about what type of chart. The suitable or recommended charts are identified by the tool automatically. But again, with this benefit, beginners might also have a bit chaos. What should I choose for? That's why this is a touch up or brush up of what charts you all had a hands on yesterday. Now coming to the composition. Comparison and composition by name and by meaning really add a lot knowledge management to the data researcher. Composition. How does the data relationships change over time? I mean, how is the relationship between the price of a product and its sale value when you study it over by a time period? This is a very easy question to answer, participants. With a common sense point of view, analytically speaking, never the price and sales are linear at a particular time frame. Then this introduces non-linearity or the uncertainty to the visual analyst. How do you present your data visually initially and then later model it predictively or prescriptively? One should start understanding the composition of the data. Basically, data composition can be broken down into two basics, that is change over time or having a statistical inherent relationship among the explanatory variables. When we talk about changing a time, I think you all had a great experience yesterday in the superstore where you projected some bar chart and you have drawn some line chart across it to identify those peaks, crests and troughs where these sales are rising by subcategory, where the profits are rising and falling by subcategory, right? You all enjoyed it. There, a great explanation was given by your mentor, igniting you all, making a thought process. How can a combination of chart, understand my language, a combination of chart, like you have a bar graph with a trend line overlapping on it, making it a combo chart. It's a combination chart to better understand these visual projections, how they rise and fall. Tableau, like as other tools like Microsoft Excel and other tools in the nature, is strongly built with this collection of combo charts coming from your stacked column, stacked bar, stacked area, and so on and so forth. But apart from this time frame related data measurements, yet another most important visualization section is understanding the proportion of the data with a certain data quantification. For instance, if you want to visualize the sales performance of a business by a segment or by a region or by a geography, you'd be rather interested to compute the performance of the sales by a region X and want to compare it over the remaining part of the business, like other regions like X, Y, Z. How to do this? Typically, if a simple part of a business performance has to be evaluated against total business performance or simple share of total, Tableau recommends us to go with the pie chart or the waterfall chart. Then stacked column is undoubtedly the most phenomenal representation when one wants to compare the component of components. Hence, either you want to go with a partition of slice of data with others or want to go for a particular region's performance over a collection, there is a plethora of tools under the composition category. Then coming to the relationship. While distribution and relation, if you can see on my screen horizontally on either side, more or less relationship is nothing but starting from understanding the distribution and exploring the inherent relationships. This is where insights or the hidden patterns can be extracted. Tableau recommends two most important chart types, namely scatter chart and bubble chart, which I think you all also have practiced yesterday. While scatter chart is a typical representation for visual modeling between two variables, bubble extends that modeling among three variables. So dear participants, take a quick snapshot of this prerequisite knowledge instrument or the tool. If one can understand this knowledge framework, what chart for what type of visual analysis, then rest of the activity with Tableau, believe me, is fun oriented learning, right? So take, if somebody wants to take, you can take a snapshot for your future reference, because rare this knowledge management comes from industry to you all. Now, here we go further. Without further ado, a lot of discussions about the Tableau environment was shared by the product community developers, the users, the practitioners, and now you believers must also get a belief at the end of the DataViz challenge. Starting with case study 1 today. Welcome everyone. Visual analytics and insights for term deposit product marketing for a retail bank. Presenting from the banking industry, typical challenges that are happening in the current retail banking industry, we have picked a frequently identified product which is being sold to customers of bank called term deposit. Research case study 1 for faculty and a typical internship project like thing for our student friends. Let's take what is retail banking at a glimpse. Many of you in our day-to-day life, you might be familiar that banks usually call us over telephones or might send emails to us requesting, alarming, awareing us, trying to aware us about their different products, among which on demand one product is term deposit. The term deposit is a special type of product from the retail banking sector offered by the bank or any financial institution, which allows us to make us invest money on it and earn certain rate of interest at a per annum or a quarter or a half yearly. So based on the investment period, technically called maturity time, the investor is going to enjoy some returns on their money that is invested. Now, how does banks actually sell this product to the customers? Let us see. Within each bank or within a particular bank, under the DBMS, database management system, or their warehouse, which I have been explaining to you all on the day 1 during the inaugural. Lot of abundant volumes and varieties of customer data are available within the database management system. Now, dear participants, my question to you all is, how do typically a banker can utilize from the available data of the bank? I mean, should the information about term deposits should be shared to all existing customers in the bank? That is option 1. Or should the banker, along with a dedicated analytics team in the backend, should do a thorough research about will this product term deposit suits to appeals to a particular customer group rather than marketing to everybody? The psychological point of view of any business says that leave no stone unturned, touch everybody, contact everybody, email everybody, and then wait for response. Dear friends, gone are these the era of this kind of practices. In order to sustain and survive in the competitive banking and finance industry, one must completely leverage successfully the IT practices, especially when we are dealing with analytics. Now, let's start with how to identify a particular customer, study his or her characteristics, and then determine or take an action whether to contact that customer or not, whether to email that customer or not, so that we can expect whether the customer will buy our term deposit product. This kind of new data-driven approach, as I said in my last presentation, data culture is nevertheless the order of the day, even for the banking industry. Now, you might ask me at the end of the day, how much is that analysis? If such a kind of analysis is done by the banking team, you might think and answer, is that analysis by the banking team really would be useful to make right decisions in picking right customers and then recommending the term deposit product to only that set of customers? So let us see how that analysis would be useful. Let me explain to you all initial knowledge transfer on how banks work. Usually, banks employ the telecalling teams, in-house teams, or they outsource this job to call center, third-party call center. What these executives in the call center do is they launch direct marketing campaigns, like they pick up a database of customer and they start telecalling us at certain times of the day. Sometimes they also prefer the traditional, conventional emailing methods. But my question to you is, as a common man, think around. Don't you think each call made to a customer and sharing about the product over a span of time like 2 to 5 minutes or 5 to 10 minutes or 10 to 30 minutes, there will be some investment cost, business cost, what we call. That is the cost of the call. Imagine if I give you 100 customers to contact and you all contacted them effectively, explained the product effectively. At the end of the day, what does the banking authority expect from us? How many customers, after being contacted, really purchased the term deposit from us? Thus, the return on the investment, that is the time, effort, and the financial element in contacting, shall all be evaluated. When we analyzed several public sector and private sector banks who are following this legacy conventional approach of business, they all approached and said, sir, we are unable to build our business further. Why? Because the customer perspective, consumer behavior in the market is very typical. Somebody picks our call and responds no. Somebody picks our call and might say yes in buying term deposit, while others don't answer, while a majority of the respondents might disconnect our call. What do you say, participants? Is this the reality or not? Right? Hence, the entire efforts of telecalling, time and effort and other resources are not being leveraged by all banking institutions effectively. Then, is there a methodology with which we can help these banking firms? Before digging out that, let's focus on how to generate the return. Each cost of the call made by a telecaller or a mailer, banking mailer, would directly affect on the profit ratio. That is how much expenses, cost expenses were made on calls versus compared to how much products, how many term deposit products were purchased by customer must be evaluated. To your surprise, the amount of expenses being made by the banking firm is like an explosive mountain, while the outcome, that is the number of term deposits being purchased, is at the foot of the mountain. How to strike an equilibrium? Who can bring the balance between the supply and demand? Undoubtedly, analytics with data culture is going to change the fate of this organization. Let us see. So here comes the problem statement in space. The problem statement associated with this first industrial project is, you are going to be given with some data set. The data is related to the direct marketing campaigns of one banking institution, of an imaginary banking institution. Now, typically the marketing campaigns were conducted by the bank using phone calls. Phone calls were made to the bank customers at random, and they started exclaiming about the term deposit. Then, when the phone calls were made, usually the client, I mean the customer, either might respond with two classes. The first class of response is, upon contact and explaining about term deposit, a customer might say yes, that is interested to buy the term deposit. So the banker or the telecaller assumes that the so-called customer might be the customer or subscriber, that is a long run customer. But usually majority of the contacts that the bankers or the telecallers do might also say a typical no as the answer. Like people, many bankers call us and offer a credit card. We might immediately say no. Rarely some of us or few of us only might say yes, depending on the need and necessity, right? So a volume of yes and a volume of no, which includes two varieties of response. So two varieties of response or a volume is now troubling the bank like anything, how to proceed further. But the success of the project is not just getting the responses from the customers, but making sure the responses are realized and received. But a typical problem in the world of ambiguous, uncertain world is, part of customers who said yes today, how sure are you that they will stick on to their decision? Yes, they might say no tomorrow. Similarly, the volume of contacts who might have responded no to a telephonic call, they might also change their thought of action and might convert into yes. Hence, some of the yes might become no and no becomes yes. Again, this becomes a much ambiguity for the financial institution. So to come out of the ambiguity and to identify the target group who might be more serious to buy the term deposit, Let's apply analytical practice on it. The objectives of the project and the challenges found in the project for your information. The objectives. The first objective today we are going to learn with hands-on Tableau is we will explore a lot of data undoubtedly, and from that exploration we will analyze which customers in the given data set are more likely to show interest in buying our retail product of term deposit from the bank. That's the primary objective of this first industrial project or the case study. The second object is we have to identify some KPIs, key performance indicators technically, with whom we will be recommending to the bank, and in terms of whether the customer will subscribe to the term deposit or not. So there are multitude of explanatory variables or input parameters that by and large would affect the buying decision of the customer. We will detect them and submit as a KPI report to the bank and empower the bank to make right decisions in the future. Third, which is the most important one, after all, learning Tableau for 4 to 5 days. Why? We will use that knowledge management of visual analytics and prove that any organization that equips, integrates, encompasses the framework of visual analytics can really find a tangible improvement and think ahead strategically and gain competitive advantage and improve the business performance. We will address all the objectives practically with the hands-on session. But before beginning the journey hands-on, let us also realize the challenges. The first challenge is, after a lot of experience with disappointment by the banking industry, they now started learning, is there a particular product that should be recommended to a particular customer only? Like credit cards, should they be offered to all customers? Like loan accounts, should they be offered to all customers? Nevertheless, this analysis is imperative, it's mandatory. If you don't do this analysis and keep on recommending offering your products, you might be able to reach the customer, may not be able to sell. Then what kind of business it would be, imagine. The second challenge is, does the time of marketing the product has to be considered? I mean, businesses usually operate on a business days right from Monday to Friday over a calendar year, that is a financial year. Is the day of operation, is the time of the operation really important for a banking firm to determine its success? We will detect that in the journey. Third, what kind of strategy should the banking team follow in order to contact and sell a product to the customer successfully? These three and a list of compiled challenges are also there, but finite, keeping the list finite, I'm planning to show only these three initially. Then let's talk about the actual instrument of experiment, that is the data set. Without data, nothing can happen, right? So let's start understanding the initial point, the data instrument. A plethora of explanatory variables, that is a collection of variables, has been given in the data set, which typically includes age. Age is nothing but the age of the banking customer in the database. Job. Each customer who has an account in the bank might be serving in a different job category. The job categories are listed in the parenthesis, participants. You can see some customers of the bank might serve in the other organizations as management, a blue collar, a technician, entrepreneur, so on and so forth. While some are unemployed also, there are students who have accounts in that banking organization who don't do a job. Is it advisable to by a bank to contact a student and sell term deposit? If contacted, will a student really buy the term deposit? And some of the job categories of respondents in the data set are unknown also. Then the next explanatory variable in your problem statement data set is the marital status. 3 levels, categories of classes of marital status were given, like married, single, divorced. Method of contacting the customer via telephone, a cellular mobile, or an unknown means. The day of the week of operations of the bank, the education levels of the customer, primary, secondary, tertiary, the month during which bank contacted the customer, probabilistic outcome. This is most important. After a contact is made, and if the respondent understood the purpose of contact and purchased the term deposit, the probabilistic outcome defined by the bank is success. Other than this, the other classes of P outcome include failure. What does a failure mean? Telecalling team has contacted the customer. Customer understood the statement but did not buy the term deposit. So the call ended up in failure. Rather than converting the customer, it just ended up in a prospect. While there are two other categories participants, that is other and unknown. It says that other and unknown. Other is some customers are very typical in nature, believe me. When telecalling team contacts, they might not immediately say either yes or no, but rather they say, give me a couple of days, give me 1 week of time, or get back to me after a fortnight. So this is what uncertain outcome, which is other category. While unknown, even banks call repeatedly, they disconnect the call and never respond. Bank never understands why they are doing this. So these are the possible classes of outcomes under the P outcome category. Then the other variables are the descriptive variables, like you can have the whether the customer of the bank owns a house, whether he's the owner of a house, yes or no. The duration of the call, which is most important, participants, you must understand. Sometimes some telecallers try to convey the purpose of the call within few minutes, while some take a long time to convey. So definitely the duration of call by and large might have an impact on deciding whether the buyer, the customer, would buy term deposit, whether has a loan application or not, or the loan account, whether the existing customer is a defaulter or not. What is meant by defaulter? Who has a loan and might have absconded or been withdrawn from the process of repayment over a period of time. A typical challenge for you all today with the real time is, should we contact a defaulter in order to sell a term deposit? What do you say, right? I think defaulters are those who never show a pattern of payment regularly. How can we sell a term deposit? Wait a minute, dear participants. All defaulters might not be 100% interested to take a term deposit. We cannot say a statement like that. Maybe a defaulter, due to external circumstances of society, might exhibit some interest in buying a term deposit. But how to identify such customer base is a typical challenge. Hence, the data are broken down into two parts, that is explanatory variables or predictors. Typically, we are going to study the age, account balance, the day of the week, the call duration, the campaign type, the previous number of days during which the last call was made, what is the previous outcome. While our target in the project is to determine whether a customer would buy the deposit either yes or no. Then possible solution. In order to build a possible solution for this project is identify the customers who are more likely to subscribe. After all, what banks want from us today in the project? Identify from the world of customers who will buy, who will not buy. Like you classify them, you cluster them, you segment them, whatever you do in your IT approach, just give us the knowledge. We will focus on them only, so that we can, when contacted, they will buy our term deposit and the activity, sale activity happens. Now, with this approach of classifying or clustering or segmenting the customers, don't you think, participants, the effort, the investments in terms of time, money, resources of the bank will be utilized effectively? Otherwise, the bank was in an opinion that everybody and anybody who is eligible to buy the term deposit, but that's not reality. All world of your customers are not your customers. Only a part of the world are real your customers. But where are those customers in that world who will help us to find? Today, analytics will help us to find. The advantage of implementing analytical practices is reduction in marketing cost. If my cost of contacting 10,000 customers in a month, in a fortnight, imagine, is 1 lakh rupees, and there is no use, there is no return found in after contacting. So you might have spent 1 lakh with nobody buying your product. Rather, blindly calling the 10,000, design and develop a strategy analytically, explore the opportunities who are more likely to buy, then build that segment target group, focus your efforts on that target group, I say. So measurable, specific, and a proper approach towards the business problem statement can thus generate a possible solution, nothing but improving the profit margin. With least customers being prospective, still you can get more profit margin for your business. Let us see a typical scenario for you all to understand before we go for the hands-on. Imagine currently the bank is planning to contact 2 lakh customers from their database. Each call made by the telecaller to the customer, imagine, is costing $5 per call. Hence, to complete 2 lakh customer calls, how much advertising budget, marketing budget the bank has to plan? $1 million budget currently the bank has. Spending money is easier, participants, but gaining returns on the spend is a real challenge. Every business must know how to earn it. Assume that the bank generates a profit of $100. Like every time a telecaller makes a call to a customer, and if the customer agrees to buy the term deposit, then how much is a profit return gain for the bank? $100. But after studying your database, it was found by the data analyst that out of every 10 calls made by the telecaller, only one customer is showing interest to purchase the term deposit. So each call is costing how much, participants? Each call is costing $5. So 10 calls will cost how much? $50. If $50 is the spent made for telecalling by the bank, and if one customer purchase out of 10, you are getting $100. Is it a profitable business or not? Till here it is profitable. But imagine on a particular day, out of 10 calls, if nobody purchased the term deposit, then what is the expense made? Expense made is $50. But what is the returns? $0. Because every day is not same day. Monday differs from Tuesday and to Wednesday and Friday also, right? That's why the reality is being told to you all on Saturday, the weekend. Then, now a typical challenge is 1 lakh participants customer database, the bank is ready to give you all. Out of 2 lakh, 1 lakh random customers were selected. Now, the bank is asking you, generate 10,000 rupees sales or $10,000 sales. How much budget you have to plan for? For 2 lakhs, you have planned $1 million. Hence, for 1 lakh, you can start with $0.5 million, half of the budget. But your challenge in this scenario, participants, is you have to generate how much sale value? 10,000 sales. Each sale generates $100. Then how to generate this 10,000? Out of 1 lakh, who will, when contacted, will attribute to 10,000? Let us see the visualization on the right side. On your right side on my screen is a mathematical graphical representation exploiting the relationship between number of customers on x-axis, percentage success outcome to occur on y-axis. Look at the blue color line, which is the basic business convention line. That is the basic line of business. Banks usually believe that the more the number of customers you contact, more is the chance for sales. How many of you agree in this? I repeat the question. The more is the number of customers contacted, more can be the sales, right? Can it happen? No, it cannot, right? Why? Because that is a probability only. That is a chance, as you all know with your common sense. But bank never considers that. Many banks, not only banks, dear friends, every business ignores this point of common sense, unfortunately. But imagine after contacting 100,000 customers, that is 1 lakh, bank earned a revenue of $50. Now bank feels proud. After contacting 1 lakh customers, we earned 50. We data scientists asked a question to the bank. Can't you get more than $50? I mean, $80 million. Is it possible? Then the bank said, of course, why not? We can get $80 million. But for that, in order to get $80 million, what bank is recommending? Look at the graph and tell the answer. Somebody put in the chat, 1 or 2. In order to get the $80 million, 160 customers, very good participants. but we asked a typical reverse engineering question. Can't we get $80 million with the same 1 lakh customers rather than 160? I mean 100,000. Bank said impossible. We said analytics will prove it. But to get to that outcome, you must understand what are the characteristics of that 100 customers. You have to explore, visualize, analyze, and model. Then based on the model solution for the scenario, your model, visual analytical model will tell who are those 100 customers to be contacted. Now, don't you think information technology is not just to convert data into information report? Today's IT is intelligent technology, not information technology only. Believe me, intelligent technology is that one, smarter one, robust, sophisticated, and makes complicated things easier for complex businesses like banking. But a typical question that you might ask me before I just take you all to the hands-on is, can this be achieved? While statement is an easy factor, action is a difficult thing, I say. Action might be difficult but not impossible, dear friends. Can this be achieved? Then if this is your question, my answer to you is, with visual analytics, with Tableau and other tools, this is yes. Again, you'll ask me, but how, sir? Again, my answer is, understand the methodology of research. Imagine on an average, when banks contact customers, let's take a benchmark that 10% of the contacted customers are likely to respond favorably. Let us go with some initial assumption. Statistically, this initial assumption presupposition is called research hypothesis or the problem statement's basic understanding. 10% of the market, let's imagine, is favorable in saying, what is meant by favorable, participants? Responding yes is called favorable, while responding no is called unfavorable situation for business. Imagine this is, but you can ask me, sir, how can you benchmark as 10%? That's why I said it is presupposition, initial assumption. It can be more than 10 also, or it can be less than 10. Let's start our experiment with some benchmark. But in reality, this probability might vary from one customer to other. Like on Monday, 10% might favorably respond, Tuesday 20%, while Wednesday it is 0%. Nobody would respond to our call. That's the reality. Then, if now banks want to find a way to advocate the rank their customers, they can divide their customers into two categories. One is most likely to buy, that is who, when contacted, are 50% confident that they are likely to buy, while the remaining category, least likely to buy, who exhibited a 5% confidence level. I repeat, when a telecaller contacted a customer, there are two probabilities, participants. One is a 50% chance of believing that a customer might buy, that is most likely, while the confidence of the speech with the customer by the telecaller was found that there's only 5% credibility by the customer to buy, then we put them into least likely to buy category. Now, this segregation of data into two categories, by and large, would allow the banker to focus accurately on who are the priority customer, who are the serious customer, who are the most committed, likely to buy customer. But it doesn't mean all those who have been segregated into least likely category will never buy. No, by point of time, by virtue of opportunity, the likely, least likely to buy might also shift to most likely to buy and vice versa. Still the biasedness, what we call veracity in big data era, the V, one of the V's called veracity, still exists. Thus, banks must focus on the right customer approach. Hence, in this slide, take the three bold highlighted points. Visual analytics focuses on right customers. Yes, offers a solution to the industry. Let's prove it. The interpretation. Let's contact. You have analyzed the data. Imagine you have visualized, which I'm going to show now hands-on with Tableau. At the end of the experiment, you found out customer profiles of 100 people. When contacted, rather than ending up in a $50 million, they all ended up in generating a $80 million sale. That means the sales or the profit margin for the bank was boosted. So you could successfully end up your 10,000 sale profit return into an increased $80. So all this outcome was actually occurring due to the analytical approaches being incorporated into the business routines. Thus, the bank, with the integration of analytics, visualizations, data exploration practices, data modeling practices, could discover a new solution for its old and evergreen problem of understanding consumer behavior. Right. So this is the internal knowledge transfer for everyone to understand before we begin hands-on. Let's kickstart our hands-on session participants without any delay. So I migrate my operation from the presentation. Let me launch my Tableau Analytics tool. Here I go. I launch my tool. Then I'll share my screen. Wait for a few seconds for the tool to open. I request all dear participants to keep your Tableau tool open on one side and accordingly practice the hands-on along with me slowly and comfortably, being mentored by Team SmartBridge in the backend for your queries, and do enjoy the session till the end. So my Tableau desktop is preparing for a launch for the data experiment. Let me share my screen to you all on the Tableau space. New share. Co-participants, can you all see my Tableau application screen space?
Yes, Mr. Mohan, your screen is visible.
Fantastic, thank you. Right.
Thank you.
All on a high fly, dear participants. Let's celebrate the visual grandeur of Tableau with the journey of application of visual analytics and insights for retail banking. In order to kickstart with the first project, Team SmartBridge has shared to all the participants a typical dataset file name bank.csv. All participants, I believe, I hope, have received this before the beginning of session, have downloaded it and ready. As already briefed by the team of experts in the last couple of sessions, Tableau is the mystic, magical tool in the world, king leader in visual analytics that can coexist with any kind of data repository, be it from a flat file to a Microsoft Excel workbook and the plethora of data repositories. Yesterday, you people might have been working with Microsoft Excel workbook on the Superstore. Inbuilt within your application is an external data repository we have shared. Please, on the connect screen, everybody, all participants on my command at a time, please select text file in the connect window pane on the left on your dashboard launching page of Tableau. Please choose text file. We are planning to connect a text file. While the typical data format for the project we shared is a CSV, separated value text file. Locate the text file where you have downloaded named bank.csv. So once you click on text file, the open dialog box appears, participants. Browse, locate the file named bank.csv at your side on your machines respectively and click open. Make sure don't select Excel file today. The file sent to you was not Excel file, although was compiled in Excel, was saved as text format CSV. If you select an Excel file and try to upload a text file, Tableau throws you an error as unrecognized file format. Right. Now, please assure all of you could successfully connect your data source to the Tableau, said data source bank.csv successfully to your Tableau workspace. Very good. So nice. Now, this is the initial data interpreter or the canvas to begin with to the world of data discovery, from data exploration to visualization to predictive and prescriptive modeling. Hence, you're being given a default sheet 1 with a lot of big data related to the consumer database of the banking institution. Now, let's drag the bank.csv data set onto the work canvas, and you can attach it here. Bank.csv, which is already loaded. So if it is loaded, then no problem. Or if you want to further edit relationships, you can edit it internally. By default, when I loaded it, it just appeared on my default screen. But if for somebody, you are a beginner and you haven't experienced the data set, you can drag it and drop it onto your canvas workspace or double click on it simply, right? So this is the data source that we are going to work with. Adjacent to your data source is your default sheet 1. Tableau is a rich collection of sheets and a collection of workbooks. Let me clear this again. System just got hanged. Just wait for a while. Hope all of you connected your data source correctly. Connected your bank.csv. Right. Yes. Right. Let me close my application and come back. There is a typical error. Yeah. Let me launch my Tableau. All of you can stay connected on the Tableau. Those who have connected, you can all go to sheet 1, click on sheet 1, and on the data pane on the left side, notice a list of all the variables divided into two typical elements, that is dimensions and measures. So become unresponsive. Provide. Close this. Let me just stop share here. Okay, I'll come back in a minute. Yeah. Let me launch my Tableau again. Memory reference challenges. Application might go into halt stage sometimes. Let me share. Now I have come back with Tableau screen again. Now you all can see that. Yes. Let me connect my text file. The bank.csv. Yes, here I go. I have my data set. So I hope all of you are ready here with this. Good, great. Click on sheet 1. Can you all see the list of all dimensions and measures participants on the data pane on the left? Now I have prepared a list of queries that we have to explore today. Data analytics basically encompasses 3 layers. One is exploration and visualization of data under the framework of EDA, that is exploratory data analysis, followed by required data cleansing or data scrubbing or data munging. Then a clean copy of the data shall be put forward for predictive or prescriptive modeling. So in the exercise project today, we will at rigor and at length, we will do a lot of data exploration and visualization. Now let me share the typical queries for you all, what we are going to do in the project. Let me share the Word document. Participants, can you all see my Word document? Also, it is visible,
Yes,
right?
yes, it's visible.
There are a list of queries that we have to answer today in the project under the EDA activity with Tableau. Then after building certain visualizations as answers for the queries, then the project deliverable that we have to build for the client bank is to build or design a corporate business intelligence dashboard that when presented to the bank will help the bank to understand the efficiency of their marketing campaigns. So first, let us start with the first part, queries for exploratory data analysis. Look out the first query, participants. The first query is asking us explore deposit buyer relationship with age variable or age predictor. While in this project, as I already briefed in my presentation, age is the one of the explanatory variables or features or predictor, while the target or response variable in the project case study is deposit, which has two classes, a yes class and a no class. How many of you think that age of the customer would have an impact or an influence on the buying nature? Like young aged people, middle aged customer, old age, elderly aged customer. If you can understand the customers from age perspective, these are the age segmentation. By and large, to a certain extent, the age of the customer might have a psychological effect on deciding whether to or not to buy term deposit. Hence, let us address this first query. I'm back to my Tableau screen again. So I'll be switching between the queries and the Tableau. So kindly follow. What we have to study here. Age is listed under your measure because age is a continuous variable. Before we do this, let's try to create some table of elements or some created dimensions. Age being continuous and spread randomly in universe, modeling the relationship between a deposit, which is a categorical item, versus a continuous. Which graph appeals, participants? Think and answer my question. Which type of visualization best appeals for you to model relationship between a categorical item deposit and a continuous variable age? This is where one has to think ahead before choosing the type of visualization. You can go ahead with a typical column chart or a bar chart to show the comparisons. How many yes category people of different age actually responded favorably? How many the unfavorable category no of different ages? But look at the volume of data, dear friends. Near 10,000 plus observations are given. Each row technically is called an observation or a case. So, or an example. 10,000 examples or observations in the raw data would certainly make a visual analyst difficult to present the data in a conventional column or bar chart. Thus, at this point, we will try to create some additional variables which are computed by the analyst. So place your mouse pointer under the measures list on the age variable. Either right click or directly click on the drop down on the age. And in the pop-up menu, participants, notice an option create is available. I repeat, right click on your age variable or age parameter under your measures. And in the pop-up menu or in the shortcut menu or in the drop down, you notice that there is a create option which is available. There is a create option which is available. Please choose create, and here you can create bins. For continuous variables, understanding the distribution of continuous variables, as I briefed at the beginning of my PPT slide, which graphs really appeal to understand the distribution of a single variable, go for histograms or create data bins to divide the continuous data into class intervals or the frequencies. So create bins here on age. You can click on bins. When you click on bins, notice on your screen the edit bins age dialog box appears. What is this bin? The minimum age of the customer in the data set was found to be 17 years. As you can see in the edit bins dialog box, maximum age of the customer was found to be 98 years. While the range is nothing but difference between maximum and minimum is 81 years. We cannot project these data points, 81 different data points, and build a complex visualization. Rather, we will classify them into suitable class intervals, frequency class interval, technically or statistically, the data bins. So each bin might accommodate 5.44 data points, or the size of the bin is custom designed. You can suggest bin size to Tableau, or you can go with the default bins. Let's go with the default bin size. Simply click on OK in the edit bin. Now, Once we added the create bin on age parameter, notice in the dimension section or the table section, Tableau has created a new parameter named age, which is now broken down by bins. So age is now being understood by the visual tool as a bin rather than an individual data point, because to accommodate volume of data, it is better approach is rather to go with a conventional bar, you can go with a binned histogram. Now age bin is there. Then let's start answering the first question, that is understanding the deposit buyer's nature over the ages. So with your age bin created in the data pane, drag the age bin and drop it into column section. The typical work culture of Tableau is technically called pivoting or pivot. The entire nature of Tableau is to rearrange, reorganize, summarize the data and present it visually. That's it. Hence, one must understand how to pivot the data with Tableau using your certain elements on the canvas like column section, row section, which you already had some good, great experience yesterday. So I request all the participants to watch carefully. Age bin, which you have created, please drag into column section, and the outcome variable. What is outcome variable? Deposit, because we want to know whether the buyer or the bank customer would say yes or no. Drag the variable deposit and drop it into the row section. Drag the variable or the data item deposit and deposit it in the row section. Now you can see a simple cross tabulation is being built between the categorical data item deposit over the continuous bin range age variable, right? So let me know, participants, could you all do this basic data pre-processing successfully? Everyone, right? So to answer the first question, we created age bins by right clicking on age and going to create command and bin section. We accepted the default bin size, age bin was created. Then we dragged the age bin into column section and the outcome target variable deposit. But a deposit being a categorical item, how can Tableau apply statistical analysis on it, or how can Tableau do analytical data mining? You need to do some other data pre-processing, that is change the method of aggregation. Tableau is rich in aggregation functions and Tableau is rich in your segregation, customization, categorization, classification. So go to deposit, expand the deposit field drop down, and here you can choose this is identified as dimension. The deposit by default, when the nature of the data is identified by Tableau as dimension, change it to measure and choose the measure aggregation as count. Please see the screen navigation carefully and perform the action accordingly on your screens. Those are doing the hands-on seriously. So the deposit drop down has to be expanded. By default, dimension deposit is treated as dimension by Tableau. Change it to measure type and apply the aggregation as count. Now, once you applied the aggregation technique, data transformation technique, and converted into a measure count, you could see a typical column graph being generated. A column graph is being generated showing the number of or count of deposit for each data age or the age bin. But preferred method or visualization to better understand the volume of data whenever the volume of data is very large is not a column or bar graph. You can go to find the trend or seasonality within it. I repeat, because we have segregated our consumer ages into bins, you are going to see those age bins here, right? So you can see a column graph. Now from the marks pane on the left side, hope all of you got this column graph successfully. Then after the column graph is generated, participants, under the marks pane, from the automatic drop down, choose a line graph, choose a line. Now the graph turns into a line graph. Notice the nature of the depositor's age on the count of deposit. But who are these? Actually, depositor has two classes. What are they? Yes and no, right? Hence, to distinguish the nature of the deposit against age, Now drag the target variable deposit and drop it into the color shelf. Okay. To make the age more meaningful, while age bin, if you see, is considered as a discrete data item. Age, which is the binned category, is now considered discrete, but rather in reality in the data, age is a continuous variable. So change the type of the data age bin from default discrete to continuous. How to do that? Click on the age bin, which is being shown as a dimension, change it to a continuous data item. Now you see on your x-axis, participants, different ages of the customers, and on their y-axis the count of responses by deposit type. That is the yes type being shown in the orange color trend line, and the no buying nature of the consumer being shown in the blue line. So this is a typical visualization solution for our first query, right? So all we did is, first we compiled the age bins by right clicking on, choosing create and bins. We compiled the bins. As such, the age bin dimension was added to our data set. Then we modeled the relationship, visualize the relationship between age bin and the deposit. Deposit is a categorical item. We change its type to continuous measure using a count function. Then we dragged the deposit into color shelf. Then we change the type of age bin being a discrete item to a continuous measure. This is how the typical line graph visualization was generated. Generating the visualization is one art, but the real art of the data practitioner is interpreting the result. The real art, the real experience, the flavor of Tableau can best be enjoyed when you as a data enthusiast can interpret this visualization. Now tell me, participants, anybody, from this generated visualization, as a banker, are you interested to study who are the customers who are more interested to react back to your telecaller? That is, which class of outcome are you planning to study in the output? Are you interested in no class or a yes class? As a business banker, all of us are interested to study the yes class only. But the pattern shows majority of the customers in the bank, look at the peaks in the blue color line corresponding to the no category of the deposit. Majority of the customers are replying with a no, but there is a portion of customers in the bank who have responded with yes. But what is that age where more people responded yes to a telecaller? Check out from the orange line which age group of customer or which ages specifically lie in the bank who have exhibited a tendency to respond more yes. If you observe the line graph, the ages from 25 or somewhere between the 25 to 30 pattern are more likely to say yes. So this is how the analytical insight through the visualization was generated from the first answer visualization which we have answered to the query. You can go with a bar graph or a typical suitable graph, but to know the trend pattern analysis, like where is that sweet spot region for the banking market to determine, so that they can focus on that particular age group. But a typical question that you all should rethink is this age group always the consistent age group for the market? Right? Maybe in the sample of 10,000 customers that we are now analyzing, the outcome determined is for the current sample, research sample under study, the prospective age group to be targeted by the bank's telecalling team is in this sweet spot region. But when you see the graph's trending pattern in the orange line representing yes category, the amount of customers responding to the telecallers yes started growing as the age grows from 15 to 25. There from 25 to 30 it is much flattened, and after 30 or 32, if you can see, the number of people responding yes to the telecaller gradually started decreasing. But if you observe participants at the age of 60, like if the customers at the age of 60 or above, what is the response rate of saying yes towards the telecalling team? It is very less. Hence, the banks shall now understand from this visual insight that the prospective customers might be in the age group of somewhere around above 20 and at below 40. Is this age group or more likely the age group who might exhibit more interest and enthusiasm to buy the term deposit? So rename your sheet, right click on sheet 1 and rename it as the deposit buyers by age. So this is the simple visual insight that you can create, and you can keep on building multiple visualizations based on the queries that are listed. So right click on sheet 1 and choose rename and add a suitable title to your chart, because this analysis, visual analysis, is describing about deposit buyers relation with age. Only typicality here is two things, participants. One is what type of chart, how to customize the visualization for a better understanding, and how to interpret it correctly. Because without interpretation, the efforts of analyst just by building chart meagerly won't give the right knowledge. So I rename it as deposit buyers by age. So the name, whatever you have renamed, will appear as the name of the sheet by default. Further, you can format it by double color that I'm leaving for the time consideration. You can later format. So the first graph was built. Now let's go back and discover the visual insight for our second question. Let me launch my Word document. Yeah. Can you all see my Word document again, participants? Is it visible?
No, no. Yeah, now it's visible.
Yes, good. Now see the second question. The second query we have to answer is find out records by age and job. Just now we discovered that age has some inherent relationship with the outcome variable deposit. Hence, let's add one more explanatory variable to the project. On this consideration, let us assume as a researcher or a presupposition point, does job of a customer might influence whether to buy a term deposit or not? Because without job, no income. Without no income, one cannot show interest towards buying a banking product. Thus, we begin our experiment by adding one more explanatory variable, that is at random a job. So let's go back to the Tableau workspace again and add a new sheet to the project. How to add a new sheet? In the status bar, you have add new worksheet button. As you all know, just click on new worksheet, participants. Your work canvas workspace is ready for you to build the next visual insight. Our next question is explore the jobs of the bank customers by their ages. So here we have a dimension or a categorical item job, and we also just now created the age bins. So to model the visualization, the previously compiled created age bin, please drag it into the columns. Request all the audience to follow accordingly. Initially, we will go a bit slow, keeping the potential of understanding of our audience. Then, once after understanding the essence of identifying the right visual tool, then we will run a bit fast to build our dashboard. Please understand this first industrial project very thoroughly, slowly, because we are going to give a practice case study at the weekend practice for you all tonight. Interested parties can participate and bring your solutions for a review tomorrow. Then this is the age bin. And as usual, here we are not interested to study the deposit nature, that is target. Rather, we are trying to model the visualization between two input parameters. Age is one input, job is another input. Does age and job have an inherent relationship together? Let's study. So I will try to now pull my measure age into the rows. So by default, the aggregation function in most statistical analytical tools, either Excel or Tableau or any Stata, is the sum function. convert the default sum function into a count function. So age bin is the age groups which are binned, while the count of age is the physical count being performed on each individual age. But we also want to know how is the distribution of ages by job. So drag the measure, dimension job and drop it on the color shelf. A bit typical custom stacked column appears. To simplify this projection, change the chart type from automatic to line chart. Change the chart type from default stacked column to the line chart by choosing the line chart from the marks pane from default automatic to the line. You can also choose this from the show me tab on the right side. Tableau lists a collection of visualizations, suitable visualizations for the analysis in the show me tab. So in this second visualization, we are trying to study as a data analyst relationship between the age group and the physical age value against a job. Now on the right side, you see the legends, data legends listed by the job, and accordingly that line trend patterns of the jobs, distribution of jobs by ages are given. Now if you want to see the characteristic of the age bin, by default it is a discrete item because it was listed as a dimension. To really represent the physical ages, convert the type of the data item from default discrete like we did in the last visualization, convert into continuous. It's very simple. You can see my illustration. Put the age bin on columns, then age variable, put it on rows. By default, sum function will be generated. Change the measure from sum to count, then drag the job to the color shelf. Finally, change the nature of age bin from discrete to continuous. Now this is a line graph showing your ages of customers on x-axis and the count of jobs by their ages on y-axis. How to understand this visualization, participants? First build it, then let's debate the interpretation. But before we do, also rename the graph as jobs by age or age distribution. The majority of the jobs, if you can see the blue color trend pattern line denoting the legend admin. Hence, what should we interpret from this graph? In our customer database or 10,000 observation sample under study, a significant portion of the bank customers are of job type admin. How many customers are of job type admin? 2,851 observations or customers are delivering a job as admin who age bin is 32 to 64. So with age distribution and the job type, we are determining the count of observations. So this is the max category. Now a typical question that you all should reintrospect is why we are doing this visualization. As majority of the customers are admin, followed by a blue collar, followed by technician. Does the product term deposit suits to these job categories? The banking manager must rethink before recommending the product. Usually, telemarketing teams will contact admin job holder, blue collar job holder, entrepreneur, housemaid, everybody they'll contact and say about the term deposit. But a point of common sense is, would all these job category people would really buy the term deposit or not? No, that is the point of reality. Without understanding the point of reality, that is a hypothesis, the experiment is carried by the bank, unfortunately. Now, my question here is, does majority job holder are interested in the term deposit? Is the product suitable to the majority job holder or the minority job holder, that is the least job holder? You can say retired and unknown job categories or student. You can see the student category listed in the green color here, somewhere in the green color, right? So number of students in the database, bank's database attributes to 417 students only. So the number of students in the present database is very less when compared to blue collar. But this graph doesn't tell whether they are deposit buyers or not. It just exploits the relationship between age distribution and job, enlightening us to throw more light on inherent patterns. Not only all explanatory variables will have correlation and target, by and large, each explanatory variable will also have a hidden correlation with another explanatory variable. This is called the problem of multi-correlation in statistical research. In statistical or analytical research modeling, a data analyst or a passionate data researcher must not only find relationships between the predictor and target, must also study the inherent relationships between predictors also, so that you can best build the model later. So this is the second visualization participants that we could address. Now let us go to the query section again. Let me share my word screen. I hope now all of you can see the word screen again. We have generated two visualizations for the first two questions. Now let's scale our analytical research by addressing the third query. The third query says, explore the relationship between education and target variable deposit. Now let's go back to our Tableau workspace, add a new worksheet participants to the current project, add a new worksheet. Now, but before going this, let me ask you all, do you think the education level of a bank customer will influence the decision of buying a term deposit? Anybody? Come on. Do you think the education level of a customer is important? Majority of us think that no, right? As Saranya says, majority of the real world human banker thinks that no need of checking the education level, let's offer to anybody. But now think from your analytical point of view. Can a student without an income can buy a term deposit? There are two chances here. Initially no, because no income. Additionally yes. Additionally yes is why? Because they can depend on the parent. Parent will buy the term deposit for the student. If the banker thinks that students are not entitled for term deposit buying, is the bank losing one customer or not? What do you say? If the banker goes with psychological thinking, no, students are not enough, they don't have income. Why? They can depend on the parent, parent will buy for it. If you don't think out of the box as an analyst, analytical scientist, you will lose one customer for your business. Then if the banker thinks, can I offer a term deposit to a housemaid? Yes, why not? Housemaid serves some houses, earns some money, can have the capability, but all housemaids have the capability to buy a term deposit, or only some of them? Is the real question has to be answered. That's why, dear friends, our next visual insight we have to generate in the project is explore the visual relationships between deposit, target variable, and education level of the customer in the bank. For this purpose, let's in the canvas take a new sheet, in the workbook add a new sheet, drag the dimension education into columns, drag the dimension education into columns, and drag the dimension deposit into rows. Whenever you want to study the relationship between two categorical variables, that is education is categorical, deposit is categorical, default visualization scheme is a cross tabulation. That's why you are not seeing any visualization here, friends. You are only seeing a cross tab summary, cross tabulation summary. But we want to convert this into visualization, as you all know, right? So let's transform the nature of the deposit from default dimension into a measure and apply a count function on it. When we transformed the dimension into measure, statistical analysis is being performed by Tableau in the backend, and a default column chart is created. Now you can see the deposits by your education level. Okay, to have a better view, change from your standard to entire view. So the graph expands beautifully. Enlarge the view to by changing from the drop down from standard to the entire view. So here you have a basic 4-year education, basic 6-year education, 9-year education, high school, illiterate, university degree. So this is the count of records by education. But we are not just interested in the count of records. We are interested in the count of deposit nature by the education level. For that, what you do is just drag the deposit into the colors pane. Drag the deposit into color pane. Now you see, you got a stacked column, right? When you drag the deposit field into the color shelf, Tableau is showing a stacked column, the composition of yes versus no. But to better model this, let us further customize the data. But let me know whether you all could do till here. So first what we did, we dragged the education field into columns pane. Then we dragged the deposit category into the row section. Then a default column chart has to build, but it did not build because deposit is a categorical item. Then we changed the attributes nature from discrete to continuous. Then the column chart was built, participants. Then we drag a deposit into color shelf. For a better view, we change it from standard view to entire view. Now click on show me tab. Click on show me tab, and you can further customize the graph by picking up your clustered one. Now you pick on the last one, clustered column. That is, you are going to cluster the no classes with the yes class. While the default one generated was a stacked, change it to clustered column chart or a clustered bar. Where is it available? When you click on show me tab, you just go to the clustered column graph, which allows you to see or visualize the two different classes under deposit, the no category and the yes category by education. In this graph, participants, it is clearly evident that as a banker, business banker, you might be interested to know which education of a customer is more likely to respond to yes. Now, if you see the data point here denoting the education university degree, that means those customers who possess education level as university degree, they have more responded yes to the telemarketers. And what is the count of that profiles? 1670. Out of the 10,000 observations in the research sample under study, 1670 customers possessing university degree as education have likely responded yes. So this is how you have segregated. So this is a very important visualization indicating impact of education on deposit buyer nature, either yes or no. At the same time, if you see the no category, surprisingly, again it is the university degree professionals who most responded no to the telemarketing things. Thus, bank now must understand a significant point that those customers who possess university degree followed by a high school education are either most likely to buy the term deposit or least likely to buy the term deposit. Visualization can just give the insight, but not the right action. We haven't created a model, participants. We are just exploring the data by Tableau visualizations only. But to know the real power, we must convert this into a predictive model using a data mining technique like a classification or a clustering based on the target variables nature. I hope so. All of you could successfully do till here. Let me know. Right? Fantastic. Really good. Yes, machine learning, artificial intelligence, predictive analytics are all possible with no coding on the Tableau platform, believe me. That's why SmartBridge has come forward to throw light, enlighten the world of data enthusiasts in association with the Tableau community to empower you all, passionate researchers, passionate career leaders, to unleash the power of Tableau into ML and AI practices also. So this is how the basic visualization. Let's rename this visualization, participants, quickly as, what is this? Deposits, deposit buyers. You can choose a right title by education. Buyer can be yes or no by education level. So this is one more graph that we created. So click outside, let the worksheet title add to the chart title also. Now let's go to our fourth query, quick in time. Let me share my word screen. Yes. Hope you all can now see the word screen also, right? Now we have built answers for 3 questions, 3 queries. Let's continue our exploratory data analysis through visualizations for the current project. The 4th question is some more exciting and challenging for all the participants. The 4th query says, identify the best days for the business. What does this mean? Usually, banks deliver their services on what days, participants? What are the working days for the banks? Usually they are from Monday to Friday for most public sector and private sector and the corporate sector banking, right? Monday to Friday. Have you ever thought on which day more customers are interested to buy the banking products? Is there such a psychological nature of the customer? Maybe or may not be. But a banker must investigate this, I say. Being a banker or a banking leader, one must take the privilege to do research analysis on what is that day where more customers are likely to respond, so that telemarketing teams can be informed about this insight and they can transform, position their actions to do more telecalling on that day. But nevertheless, consumer behavior is same on all days. Please remember this basic point of business. Now I'm switching to Tableau again to address the 4th question, that is identifying the best days for the business. Let's add a new worksheet, participants, sheet 4. So we have done deposit buyers by age, jobs by age, deposit buyers by education. Now sheet 4 is let's learn the best days for business. So in order to do the best days for business, what are the variables that we have to visualize? Fortunately, in your data set, one of the parameter is named day of the week. Please identify that data item under your dimension section, day of the week or table section. How does day of the week associate or relate to deposit nature? Let us see. So drag the data item day of the week and drop it in columns. Drag day of week and drop it in columns. And the target variable deposit shall be dropped in the row shelf. Day of the week goes into column shelf. Deposit will go into row shelf. Both being categorical, Tableau just builds the cross tab summary. No visualization is created here, like we found in the last time. All of you do this 2 steps. Now, transform the data nature of deposit from dimension, choose the measure count. Same process for most of these data practices in the project. Now, when we choose the count function, the dimension deposit got transformed into a measure. As you can see, measure the green color. And typically a column graph bar is generated denoting the effect of the day of the week on the target variable. On x-axis, participants, you can see the days of week running from Monday to Friday. The bank is working from Monday to Friday. On y-axis, you can see the count of deposits. But specifically, we are interested to know which days of the week are people either most likely to buy or least likely to buy as per the probability. For that, just add your deposit variable to your color shelf. I repeat, day of week should go into column shelf. Deposit should go into row shelf. Transform the deposit dimension into measure by choosing count function in the drop down. And finally, add deposit to the color shelf on the color shelf. Now you got a stacked column. If you want to go with the stacked column, you can keep the visualization, but for more better understanding, refine the visualization by clicking on Show Me tab and choose the bar graph. And choose the bar graph. This is the bar graph, the horizontal bar, denoting the impact of the effect of the day on the volume of deposits. Then finally, drag the deposit once again into color shelf. I repeat, by default, we got a column when we change the deposit into measure. Then click on Show Me tab. Under the Show Me tab, you have the default bar graph section in the vertical horizontal visualization section. Then choose the horizontal bar, recommended, as Tableau is saying this is recommended. All graphs you can show for a pie graph also. So I'm going with the bar graph and drag the deposit into color. Now notice, participants, the effect of day on the nature of deposit by no and yes are being visualized. Identify from the visualization, identify, because as a banker you might be interested only to study the yes category. You don't want the no category. Later we'll study the no category. Coming to the yes category, on which day customers are most likely to respond yes. Identify from the visualization which is that magical day for this bank, for the given data set, which is that prospective day most customers are likely to say yes. Is it Monday, Tuesday, Wednesday, Thursday, or Friday? Right? Which is the one? Yeah. So this is the Thursday, right? Thursday, as you can see the length of the bar, more than 1,000 customers on Thursday are saying yes to the telemarketing team. Okay. Then again, if you see the no category participant, the no category is shown by blue color. Number of customers responding as no to the telecaller is how much? 7,578 customers are likely to say no on a Thursday, while 1,000 odd customers are likely to say yes. So Thursday is a magical day for this bank. Chance of saying more likely or least likely. So we can rename this sheet as best days for business or best days for marketing. To use the right word, best days for marketing. Thursday would be an auspicious day for the bank to contact, followed by your Tuesday and followed by your Friday. But look at Monday. When telemarketing teams do wake up calls on Monday to their customers, the response rate for yes is only 847 customers out of 10,000 are saying yes. Very poor response rate on Monday. At the same time, majority of the customers on Monday respond no to a telecalling team. What does this visual insight hint us? It is advisable for the bank not to contact the customers on Monday, rather to focus on Thursday, followed by Wednesday and Tuesday. These are the right business days to focus the telemarketing efforts. This is the best days for marketing, right? So we have built 4 queries and 4 visualizations for 4 of our queries. So it's very simple. Add drop by drop knowledge insight to your project. Let's go back quickly to our query section again. Let me share the screen on the query section. So we have identified the best days for business. Hope you all can now see my word screen, right? Now the 5th query,
Yes.
participants, if you can see, the 5th query is, do deposit buying nature vary over the month? The data analyst must think from this insight also. Does month of the calendar year or the financial year of the business, does it have effect on the nature of the consumer's deposit buying nature? Obviously, who knows? January might give me more customers, while February might give me least customers, while March might give me 0 customers. Hence, it is our next step to analyze, visualize, does month has a significant effect or relationship with the deposit buying nature? Let's discover that knowledge factor. Going back to the Tableau canvas again, here I go. Add a new worksheet, participants. Continue your journey of data enthusiasm, untired, retired, I say. Yes. So let's continue the visual exploratory analysis by modeling a visualization or relationship between month parameter in our data set. Drag the month into the column shelf, and the same old target variable deposit, drop it into the row shelf. While both being categorical, again I'm stressing, any analytical statistical tool will just build a crosstab summary without any visualization. Transform the target variable from dimension to the measure count to get a default visualization. The default preferred visualization is between a categorical and a quantification. The default is column chart for any tool. The categorical is month, and the measure, the continuous, is now the deposit, the count of deposit to exactly say. So this is the default visualization we got. So the months are denoted from the March to December in the current banking system for their financial year. More number of depositors tend to show enthusiasm in May, but we don't know whether they are saying yes or no. To distinguish, just drop the target variable deposit into the color shelf. We got a stacked column again. If you are okay with the stacked column, leave it default. But if you want to refine the visualization, click on Show Me tab and pick up the clustered column, which clusters the classes yes and no by the month. So what we did, participants, in the fifth query, it's very simple. We dragged the month variable into column shelf, deposit variable into row shelf, transformed the dimension deposit into measure by choosing count function. We got a column chart, added the deposit variable into the color shelf or the colors card. Then we just choose the default stacked column into clustered one. Now this is a beautiful visualization detailing us the relationship of or the impact of month on the outcome of deposit, either yes or no. Now to determine what is that magical month during which more customers are saying yes, you can change the standard view to the entire view for a better view. Pick up the interpretation here on the yes category. Focus always your attention on the positive class. Positive class is yes class. The negative class of the project is the no class. Majority of the customers responded yes to the telemarketing in which month? Majority of the customers responded most likely in the month of May. Hence, from this visual insight, banks learn a data pattern that May is the prospective month to do more telemarketing to this nature of the customers. But on the left side, participants, if you see, again, a typical biased pattern is coming out. Again, for the no class also, it is the month of May where majority of the people said no, right? So May is a typical month followed by June and July for business exploration to generate prospects in terms of yes and no. While if you see the March followed by September and October and December, I think these months haven't have a significant impact on the business. The proportion, the composition of the outcome against the month is least significant or highly insignificant, we can say. Thus, our significant months of interest fall as May followed by June, July, or typically the August month. So this exploration visualization is now saying about what? This is about the deposit buyers by month. Deposit buyers by month. Rename the sheet as deposit buyers by month. Please make sure, participants, you could generate such a visualization with the visual presentation what you are seeing on screen. See the fields, you can see what are going into columns, what are going into rows. They are being aggregation, data transformation is being performed on the target variable only always, that is the deposit. Rest all are very straightforward methods, nothing typical. Right. Okay. Very good question. Why are more calls being made on May? Reverse engineering. This is the nature of the business, line of business actually. It was found that in the calendar year at this banking institution, targets, the set targets given by the marketing team leaders to the telemarketing team, the goals were set like that. Actually, the visualization also gave another insight as pointed by one of our audience, the participant. It's a good practice that they have brought out. The set targets given by the project are defined like that. Fortunately, our outcome is not only to address that May or more calls, May can be a defined benchmark for the banking in their regular practice. Analytics brought out that insight also. Maybe for this bank it is like, maybe for other banks this is not the standard. Maybe other banks might do more number of calls in August or December also. It's the nature of the business process and the role of the activities and responsibilities of the people power that analytics brings out evidently. Right. Now let's go to the query section again. The query section says the next important query. After studying the nature of the deposit buyer by age, by education, by day of the week, by month, explore responses by age group. Already we developed a visual presentation on the age with a line chart. There we have created age bins. But a good practice whenever you are working with big data volumes and varieties is group your data. Does data groups does have any inherent patterns and relationship with the target variable? Let's see. Whenever you are planning to group your data participants, imagine, use your common sense point, you have to group a continuous measure, right? Continuous data can be grouped technically. Let's go back to the Tableau workspace, add a new sheet into the project window and continue our exploration. So I'm adding a new sheet here in the space. Now the next most important step requiring typical data pre-processing. Data pre-processing takes place in this visualization. More effort has to be put by the data analyst or the visual analyst. Our idea here is, do deposit buying nature vary with age groups rather than individual ages? An individual age by and large has some relationship, but if we take a collection of ages and group them, can some customers in the age group might typically say yes or no? Let us discover an answer for this query. But for that, first let us create an age group effectively. Like we created a bin. If you all remember the very first visualization we started today, age bin. Let's create an age group. How to create an age group, participants? Take your mouse pointer on the age measure, click the drop down or right click, and in the pop-up menu, you have the create option. In the create, last time we created bins. Now let us create a group. Okay. So this is the navigation that you have to do in your new sheet. Add a new sheet, right click on age or click on the drop down age, go to the shortcut menu create and the cascading menu group. Click on group. Now the create group pop-up appears. The create group pop-up appears here, as you can see. Individual ages of the customers of the bank are given. What is the minimum age participants starting with? Identified is 17 years of a customer and scaling up to a maximum of 98 years. So ages are spread in over a distribution. I am planning to divide my age groups in a certain category. What I do is, first I'll start with an age group called less than 22 years. I will try to select, click on the 17 in your create group dialog box, participants. First click on the first age 17, hold your shift key on your keyboard, select the ages 17, 18, 19, 20, 21. I repeat, after opening the group dialog box, click on the first age parameter 17 or the age value 17. Then select the ages 17, 18, 19, 20, 21 with your shift key for multiple selection. After selecting that, identify there is one button called command button, clickable button called group. Click on it. Tableau is now asking what name you want to give for this group. Simply type less than operator and say 22. Less than 22. So what does the group less than 22 represent? Less than 22 group is a collection of ages from 17 to 21. Why we are grouping the data? What is the essence of grouping the data? Rather than studying, exploring impact of each customer age on the outcome, sometimes it is advisable to create data groups to see the combined effect on the outcome. To see a holistic effect on the outcome, data groups are recommended in visual analytics practice. So this is the less than. Now to create that group, see the triangular drop down here, the arrow showing downward. Just click on it, it will expand to the right side. By default, it is downward when you create. Just click on it, it will show towards the right direction, indicating that a group is ready to be attached to the data set. Continue the practice, participants. Select the ages 22, hold your shift key, click your down arrow key on your keyboard, continue selection till 27. So select the ages 22 to 27 with your shift key for multiple selection and down arrow, and Now click on group button again. So what is this age group? Technically, statistics calls this as your class interval, frequency interval for the continuous measure. So this age group is 22-27. So to add this group, just click on the triangular drop down. It will show towards the right side, ready to get attached. Continue the process. The third age group is from 28 years. So select 28, 29, 30, 31, 32, 33, 34, 35. This is your choice. Just for the project demonstration, I am randomly picking ages. There is no mandatory rule that you have to pick the same class intervals. You can define your own class intervals, participants. 28 to 35, click on the group and rename it as 28 to 35. Just click on the drop down. Now the group is attached. Continue the process. Select the age 36. Continue the selection with your shift key. Take it till 50. 36 to 50 is the next group. In order to create a group after selection, click on the group button and give a meaningful name to the group 36 to 50. You can write 36 to 50 years also for a meaningful name 36 to 50 years. Now click on the drop down arrow. That group is added to this thing. Continue your selection of the ages. Select till 65 participants. Don't worry, once again I'll show it. I may run a bit fast, keeping in time. Don't panic. Once I create age groups, I'll show it again. 51 to 65. Do the selection. Click the group button. Name the group as 51 to 65. Click on the drop down. The group is added. Now, the remaining ages in the data set from 66 onwards, select all of them by default at a quick time. 65 to 98. I am planning to group them and name this group as greater than 65 years. So this group of customers are those who are above 65 years. So simply click it. Now check out all your raw data of the customer ages have been categorized, grouped into 6 different groups. So I'm clicking on drop down for the benefit of participants. Less than 22. What are the ages? 17 to 21. 22 to 27 participants. What are the ages? 22 to 27. 28 to 35, third group. 36 to 50, fourth group. 51 to 65, fifth group. Finally, above 65 is the sixth group. So you have divided your entire data of the ages of the customer into 6 different groups. All of you, please do this a bit patiently and correctly so that we will now unleash the power of Tableau to determine the impact of the age groups on the deposit buying nature. Less than 22, check out on the screen and then group it accordingly. Those are doing the hands-on. Once done, you can click apply and click OK. And when you click OK, participants, you can notice in the dimension section, age group will be created. A new dimension age group will appear under table section. Click apply, click OK. Check out. Yes, successfully we have created the age groups. Right. So how we have created the age groups? When you click on edit age group, actually how to do that grouping, I am once again showing for the benefit of our participants. Aishwarya, watch it. You have to click on the age measurement. All participants check out age, go to create option and group. For any measure, this is the navigation to create groups for that measure. When you click on group and when you click on group this thing, you can see your create group dialog box appears with raw ages. You can plan your class intervals like how I did 17 to 21. I have selected the ages and clicked on group button and named it as less than 22. That's it. Selected the ages, clicked on the group button and gave it some name of your choice. Likewise, select your age groups, name them and click apply, click OK. When did, we got one more dimension added to our dimensions list, age group. So the greatness of Tableau is you can create new fields from your existing fields as a measure or a dimension also. Now the typical question we are going to address is study the impact relationship between age group in columns. So drag age group. Just now we have created age groups, put them in column shelf, and the deposit buying nature into the row shelf. And the deposit buying nature into the row shelf. Because deposit is a categorical item, age group is also categorical. Each age group represents a particular category of ages. Transform the deposit into a measure like you are doing regularly into a count. Now we got the default column graph. Now question here is, which age groups are most likely to say yes and likely to say no? So drag the deposit into color shelf. Drag the deposit into color shelf. This time, rather than going with a column graph, I'll go with a circle graph. So you can, once dragging the deposit into color shelf, choose the automatic drop down pane and choose circle. Now notice the circles appearing. The orange color circles denote which outcome? Yes. And the blue color circles denote which outcome? No. We have created age groups, modeling the visualization between age group and deposit as a measure of count and by colorification. Now identify these participants, tell me which age groups are more likely to say yes. From the visualization, check out the age groups are shown on x-axis, count of their responses are shown on y-axis. Age groups 28 to 35, age groups 36 to 50 are more likely to say yes. Thus, this practice of visual intelligence of the modern business intelligence is the new operational IT for organizations to explore the real insights. Which age groups are least likely to respond? Check out the age groups 22 to 27, followed by 51 to 65, followed by greater than 65, less than 22. They are least significant responding. Hence, telemarketing teams are now informed by the visual analysts that focus more on calling age groups of customers fitting between 28 to 35, followed by 36 to 50, 51 to 65, because they are more likely to buy. Right? This is the visual practice, right, of how we have built. To add more life to this graph, select all data points. I mean, right click on a data point, choose select all, and simply say mark label and choose always show. I repeat, to make it more informative, to show the labels on the data point, select all data points first, then right click on any data point and mark label always show. This will show the number of responses under an age group by deposit category. So creating that group is typically the actual success. Select your age groups less than 22. If you, some people want to see the age groups, as some of them are doing hands-on, I think I'm just showing it for your benefit, participants. Check out the age groups, participants, faculty friends and student friends. Less than 22, 22 to 27, 28 to 35, 36 to 50, 51 to 65, and greater than 65. This is for your benefit. Again, I'm illustrating. So create 6 groups like this, then model the visualization between age group and the deposit nature. Hope those who have posed in the query chat, I have answered for your convenience. Those age groups are illustrated, right? Good. Then prepare the visualization like this, friends. Age group on column shelf, count of deposits and rows. That is, deposit has to be transformed into measure by choosing the count function, and drag the deposit into color shelf and label them. How to label them? Select all data points have to be selected. Then again right click, choose mark label, always show. Always show. A majority of the people age group of 36 to 50 are likely to say no, while a minority in the group are likely to say yes. So typical characteristics of the consumer behavior is understood here with this graph. So we have answered almost 6 queries, participants. Yes, you can edit it, Vatsala. Any axis can be edited. You can select the x-axis or y-axis. right click on, and you can choose edit axis. Customization of the graphs is at the discretion of the user of the Tableau. Tableau users can customize any axis. Default representation is automatic. When you choose the axis automatic representation, you can choose fixed or you can choose any method. Let's rename the sheet participants quickly without delay. What is this sheet means? Deposit buyers by age group. Okay. Now, a required thing before we go to dashboard, we have to add some filters also. For my convenience, let's add the filters here. Let's add a show filter. See how I'm doing? All of you do this. Show filter on age group in this worksheet, so that the age group filters appear on the right side of the graph as legends, which are very useful to build the dashboard. So what I did in the current graph, I clicked on the age group, clicked on show filter. Like that, for other graphs also, that is deposit buyers by month, activate the sheet named deposit buyers by month participants, those who have done. Then click on the month name, click on the month attribute drop down and choose show filter. So this graph will have the filters as month names. So for deposit buyers by age group, add the filter on age group, add the filter on age group. And for deposit buyers by month, in the worksheet named deposit buyers by month or whatever name you people have opted for, please add filter on show filter on month. Similarly, for the worksheet named best days for marketing, for one of the worksheet that we created in Tableau today, where will we add the filter? You can add a filter on day of the week. Please show filter on day of the week. Filters really add a lot of value during data revisions. And for deposit buyers by education worksheet, please show filter on education. That's it, enough. So add respective filters at each sheet whenever required. Currently, we are in the worksheet named deposit buyers by age group, where we have added filter on age group. Hope so all participants are clear with the illustrations demonstrated so far. Now add finally a new sheet because we are left over with one more query. Let me go to the Word document. Let me share the Word document again to show you all the queries. Hope you all can see the Word document participants again. Finally, we are at the last query, last visualization to be built before we go for the dashboard. The last query says study responses by call duration. Study responses by call duration. Now, before I build a visualization, let me question all the participants, and so that let me see how many of you can answer. Do you think call duration by a telecaller will have effect on the deposit outcome? Come on, ma, everybody, all at a time, be energetic. I know on a weekend, staying this patience is not great. That's why you are data passionate researchers and career leaders of tomorrow. Very good. Fantastic. Call duration. Some telecallers doesn't understand this. They say they'll keep on speaking minutes and minutes. The customer gets irritated and bored and might say no. Do you agree? Actually, at the time of call, the customer is interested. But because of the lengthy call duration, customer changes his opinion and says no, or I will think later. Sometimes telecallers speak sweet and light and share the real tight decision, and they convey the meaning. Customer might say yes. And those who are in the notion or in the mindset of saying no might still say yes. Thus, dear participants, never underestimate call duration. Call duration will change the game certainly at the end of the day. Thus, my last visualization for today in this project, add a new sheet. Let us explore the relationship between duration of the telecaller's call and the outcome deposit nature. So let's add duration. So we have here the duration is a measure here. So duration is measured, but before going to duration, we have to divide the call duration into certain groups. Why? Because in the raw data which we gave to you, call duration was measured in seconds. Usually the call duration is measured in seconds. let us group all those seconds into minutes. How to do? Those people who didn't understand grouping last time, now watch my activity and understand and replay back on your screens how I am creating data groups for duration measure. To create data groups for duration measure, just click on the drop down on duration or right click on duration participants.
Excuse me. Yeah, Mr. Mohan, your screen is not visible for the Tableau. So
Okay,
can
I'm
you please
sharing
share
it
this?
again. Thank you, Shubham. Yeah. Now is it visible? I hope.
Yeah, now it's visible.
Fantastic. All players on my command at a time. Again, my idea here is let's group the call duration, which actually in the raw data was given in seconds. Let us divide the call duration of seconds and create groups as call duration in minutes. To do that, watch the on-screen demonstration. Click on duration. In the pop-up menu participants, notice a command create is there. In the cascading menu, there is a command group. For any measure, whenever you are planning to create groups, follow this navigation. How did I open this? Once again, everybody, click on duration parameter. On the drop down, the menu opens with create and choose group. Now follow the navigation and accordingly do it slowly. Click on group command. This will launch create group duration dialog box. I hope all participants can see the create group dialog box. Everybody? Yes, good. Initially, we will start with 0. That means no call at all. A call with 1 second, call with 2 second, 3 second. Like that, if you see, the call duration is spread from 0 seconds to a maximum of 4,918 seconds. Rather than modeling the visualization in terms of seconds, let us drill down these seconds into minutes. For that purpose, we are creating the groups. Now, we are creating the groups like this. We will divide the entire call durations of the customers into 6 groups, starting from 2 minutes, 2 to 5 minutes, 5 to 10 minutes, 10 to 15 minutes, 15 to 30 minutes, greater than 30 minutes. I repeat again, participants, for your benefit. The entire call duration in seconds is now broken down into 6 groups, namely 2-minute call duration, 2 to 5-minute call duration, 5 to 10-minute call duration, 10 to 15 minutes, 15 to 30 minutes, and greater than 30. What is meant by 2 minutes? 2 minutes equal to how many seconds, participants? 2 minutes equal to 120 seconds, as you all know. So select from 0 to 120 quickly. All players, watch the on-screen man. Come on. Select from 0 to 120 with your shift key and down arrow key or with your mouse. Exactly till 120. And call this as your first group. 0 to 120 is called 2-minute duration. So select 0 to 120 seconds, click on group button and call this as what? 2 minutes. Rename this as 2 minutes. Click on the drop down, first group is created. Now the next group, 2 to 5 minutes. What is meant by 2 to 5 minutes? 5 minutes equal to how many seconds? 300 seconds, because each minute has 60 seconds, as you know mathematically. So start from 121, hold your shift key on your keyboard, keep on selecting till 300 in sequence, keep on selecting them fastly till 300 exactly. So this is the second group of call duration between 2 minutes to 300, 2 minutes to 5 minutes, that is 120 seconds to 300 seconds, technically the conversion. Click on group button, name the group as 2-5 minutes. 2 to 5 minutes. Click on the drop down. Now we have created second group. Continue the process, participants. The second group is 2 to 5 minutes, that is from 121 seconds to 300 seconds. Continue the third group, that is 301 seconds, 5 to 10 minutes. 10 minutes means how many seconds? 10 minutes means 600 seconds. So start selecting from 301 till 600. 301 till 600. Keep the selection going on rapid and in quick succession. 600, exactly stop at 600. So this is the third group we are creating, named as 5 to 10 minutes. So name the selection as 5 to 10 minutes. Click on the drop down, add the group. Continue the data pre-processing activity. 10 to 15 minutes now. 15 minutes has how many seconds? 15 minutes has, come on participants. Very good. Select till 900. Select till 900. Rapid succession. This is the largest call duration. 15 minutes is the largest call. So it encompasses more seconds here. Yes, exactly 900. Group it and call it as 15 to 30 minutes. Good. Now continue your calculation here. That is greater than 30 minutes. Whatever are after 30 minutes, you can continue. So this is what I have named. Just check me. This is called 2 minutes, 2 to 5, 5 to 10. This is, sorry, 10 to 15 actually. We have to edit it. This is called 10 to 15 minutes. Edit the group name. Just click on it. Rename it as 10 to 15. I have just here and renamed it as 15:30. All participants, please correct it, ma'am. 10 to 15 minutes. Now continue your selection from 601 and till 900. That would be from 15 to 30. 2 to 5. Just a second. Let me check out what are the groups created till now. We have the groups created as 2 minutes, 2 to 5, 5 to 10. Then we have 10 to 15 is now being created actually. 10 to 15 is the group already created. Right. Let's continue further below. Okay, this is a group. It has to be modified. 5 to 10, 10 to 15 has to encompass till 900 only. Okay. 2 to 5, 5 to 10, 10 to 15. Now select from 15 to 30 minutes. This is the selection participants. That is from 901. Please continue selecting 30 minutes equal to how many seconds? 1800 seconds. So keep on selecting your time frame in the create group dialog box till you reach 1800 or less than 1800, whatever is the seconds given in the data, raw data. From 901, please keep on selecting till 1800 only. So 1788 is the last. Notice it. We were given in the data 901 to 1788 seconds. Call this group as which group participants? 15 to 30 minutes. So this is the fourth group we have created. 15 to 30. Fifth group, I think. Yes. This is the fifth group. 1, 2, 3, 4, 5. And whatever are above 1800 seconds, the call durations which are above 1800 seconds, we will select the remaining ones, quick succession, and we will call them as greater than 30 minutes. We'll call them greater than 30 minutes. That's it. We have created 6 groups. 2 minutes, 2 to 5 minutes, 5 to 10 minutes, that is 600 seconds, 10 to 15 minutes, that is till 900 seconds, 15 to 30 minutes, that is still 800 seconds, but we have only 1788 there. Then whatever are above 1800, you can plan it greater than 30. Please make sure all of you group your data like this for the current demonstration. So total we have 6 categories or 6 groups all in. Once you click apply, click OK, you will get another dimension added to your data set named duration in groups. So participants, before you click apply OK, check out your grouping activity correctly. 2 minutes is 0 to 120. 2 to 5 minutes is 121 to 300. 5 to 10 minutes is 301 to 600. 10 to 15 minutes is 601 to 900. 15 to 30 minutes is 901 to 1788 because we didn't have 1800 exact call duration. Then whatever are above 1800 participants, finally we grouped them into greater than 30 minutes. Click apply, click OK. Now the question asked is, study the call duration versus deposit nature. Let us see. So pick up the duration group dimension into columns shelf and pick up the deposit into the row shelf. Duration group into the column shelf and deposit nature into the row shelf. Because both are categorical, crosstab summary is given with no visualization. Change the nature of the deposit from dimension to the measure by choosing the count function. Now you can see on the x-axis you are seeing call duration participants and y-axis is the count of deposits. To make the outcome more realistic, drag the deposit variable and drop it into the color shelf. Drag the deposit variable and drop it into the color shelf. You get a stacked column, but if you want to show a clustered, go to the show me tab and choose the cluster. Now check out the response rates, deposit buyer response rates by call duration. This is the actual visualization that we should produce. Majority of the respondents or the customers of the bank are either likely or unlikely to say yes or no during which time frame? Either in 2 minutes or 2 to 5 minutes. But majority of the people said yes in which call duration time frame? So check out the visualization. We have chosen the clustered column here, right? By default, you got a stacked column. Majority of the customers answered yes to a call duration of 5 to 10 minutes. But if the telecaller tries to continue more than 10 minutes, the response rate of yes is decreasing. What does this insight convey to the bank's telecalling team participants? Anybody? Any telecaller to generate more positive responses must limit their call maximum of 10 minutes. Very good answer, Chandana. Very good. Not more than 10 minutes they should speak. Unfortunately, these telecallers don't know and they keep on speaking blah blah to the customers. But no customer even allows a 10-minute call. They are the polite, decent customers. Hardly 2 to 5 minutes is the approachable, while the likely is 5 to 10. But at the same time, in the bank, dear friends, notice on the left side in the no category, there are customers who end the call or might say no within 2 minutes or 2 to 5 minutes also. Within a 2 minute or within a 2 to 5 minute, most likely they'll say no. But if you continue your call from 5 to 10 minutes or more, observe the no pattern, negative class column graph. If the telecaller speaks very impressively or very decent, polite and understandable communication, and as the call duration increases on x-axis, number of no's on y-axis are decreasing. Thus, to convert more no's into yes, it is sometimes to continue speaking, while sometimes it is not reasonable to speak more. That's why telecalling is a very smart activity and very challenging activity. The energy, context of speech, language used for speaking, ability to control the psychology of the audience is the ability of the speaker always that would impact the conversion greatly. But without any context, without any relevancy, if a telecaller speaks, it's a disaster, dear friends. Believe me, the entire call goes into a wastage. So this sheet, we will rename it as, come on, what shall we rename? Deposit buyers by call duration. Call duration. So we have built 7 typical visualizations for our industrial problem statement of research on banking analytics for term deposit for retail bank, right? Hope all of you, by and large, with your great concentration and your patience, appreciable patience, have understood my efforts till here. Yeah, yes. So 7 things are done. Now let's celebrate the visual grandeur with a Tableau. That is the phenomenal dashboard. Yesterday, with the mentors leading capabilities under his supervision, you all, after building certain number of visual schemes, you then pulled all the visualizations into the final visualization, that is your dashboard. How to add a dashboard, participants? On your status bar, adjacent to new worksheet button, you have a new dashboard. But before doing this, like we did, add a filter to the deposit, the duration group also. I request all the participants, those are in the current worksheet, please show a filter on duration group. These are the filtering elements which are going to play a vital role in the dashboard, right? So let's revisit. We first build the first visualization, deposit buyers by age. Then we just build a intercorrelation visualization, jobs by age. There is no deposit variable here. Then we built deposit buyers by education. Then we built best days for marketing, deposit buyers by month, deposit buyers by age group, deposit buyers by call duration. Let's build a very simple dashboard today by pulling the appropriate visualizations. I click on new dashboard. Can you all see my dashboard canvas, participants, everybody? This was already discussed very greatly by the expert yesterday. Right now, abundant sheets are available on the left side under sheet section, and you have the dashboard and its layout. At this juncture, I'll comment on how to build a dashboard, how to visualize this dashboard on different devices using your device preview, and then you can make this dashboard go public also. Making the dashboard public, I'll reserve that part of speech based on the time availability for tomorrow's final journey session. But today, let's build a celebration of data visualization. From the available visualizations, participants, identify which visualizations really give a lot of insights to the bank so that we can pull them into the dashboard. I repeat once again, we have built many visualizations by age, by month, by day of week, right? Which do you think are more critical for decision making for the bank's telecalling team? Come on, use your common sense and opt. Very good. Best days for marketing is one thing. Very good, Pratibha. Call duration, age group, by and large, most of them will matter, right? So let us limit our dashboard to a couple or a triplet of visualizations. As you all recommended, I will try to pull best days of marketing into my dashboard. I request all other participants also to do that. So the first visualization I am dragging into my dashboard canvas workspace is best days for marketing. On the right side, if you see, its visual filter is also available, day of week, right? There is a purpose why I advise you all to add this filter. Now let me reveal the purpose. While this is the visualization and this is a filter, we can customize this. Just click on the day of the week filter. Just click on, you will get 2 buttons named remove from dashboard and more option. All of you, first add this dashboard and click on this day of week. Click on more options. Click on more options. If you want, you can make this a customizable element also. Then under the more options, when you click on the filtering element, you can see more custom graphics, customization on dashboard. Please choose single value slider or single value drop down for your information. How did I get this? Once again, I'm showing. I have added best days for marketing onto the dashboard. I clicked on the visual filter element and I got remove from dashboard, fix height, and more options drop down. From the more options drop down, I am choosing single value slider. Please click this, participants. Now your filter turns into a slider. These are called dashboard elements. Very important to convert the filters into elements. We have converted the filter into element. Then Make it as a floating. How will you make floating? Just click on the more option and click floating. When you make it floating, you can pull the element anywhere and position it anywhere as per your choice. So two things we did. One is on the visual filter. We applied a slider option and made it floating. Keep it ready and put the slider default all days. Now you can see when I click on this slider, the dashboard, the graph tunes accordingly to the slider to make the element more interactive. Such a dashboard is called interactive dashboard in Tableau for information. This is called interactive dashboard. So this is best days of marketing. Now, as per your recommendations, I have noticed in the chat, some of you audience are asking to put best days in the month, deposit buyers by month. So I am selecting that graph, deposit buyers by month, right? So this is the deposit buyers by month. And you can also use this here. And if you want based on your size, which you can customize based on the size of the dashboard, you can escalate, decrease, or increase the height and width. So let us go with this initial dashboard. You can build a multiple dashboards with multiple collection, or you can add more elements based on the size. You can reduce this, or you can reduce the visualization size for more inclusion of more dashboards possibly. You can reduce this size and you can position it accordingly. Pull it upward and you can place it somewhere here. You can place them side by side also if you want. Here, if you see, let's add the month filter here. Go to the worksheet named. Yes, we have a month filter, but because of the size, it is not being shown. Let us reduce it further. We have a month filter here. Now this month filter, let us convert this also into a slider as we did. So keep on single slider participants and make it a floating element. Just click on the drop down and you make it all here. Drag the slider and position it exactly on this thing. Now on my dashboard, as you are seeing, there are two visualizations. One is best days for marketing, deposit buyers by month. On which days telecalling team should call and in which month when called they get more buyers is the actual knowledge we are trying to represent via the dashboard. So these two elements sliders have to be created. But before we go and do this, let's go to the corresponding worksheets. What are the worksheets we inserted? Once again, click on best days for marketing worksheet. Click on best days for marketing worksheet participants. Note the very important connectivity which I'm establishing for the dashboard to be interactive. Currently, I'm in the best days for marketing. In the filter section, click on day of the week. Click on day of the week and choose the option apply to worksheets. When we filter the days, come on participants, its effect should be seen on the next worksheet. What is the next worksheet we inserted in the dashboard? So go to selected worksheet. Which worksheet should accordingly get filtered based on day of week? It is deposit buyer by month. I repeat once again, focus on after inserting two worksheets into the dashboard, that is best days for marketing and the deposit buyer by month worksheet, go to the best days for marketing worksheet or activate this worksheet and click on day of the week in filters and choose the option apply to worksheets and click on selected worksheet and show to Tableau. When we change the days of the week, which worksheet should accordingly become interactive? The worksheet named deposit buyers by month. Only this worksheet should get affected. If you want all worksheet to get affected, select all. And if you want only particular one, select the particular worksheet. Click OK. Similarly, go to deposit buyers by month worksheet. Go to deposit buyers by month worksheet and go to month filter. And when we change the month slider, that month slider should interactively affect which worksheet? That is deposit best days for marketing. This is vice versa simply. So from the best days, you will connect to the month worksheet. From the month worksheet, you will connect to the best days, vice versa. That will make the dashboard more interactive. Then use one of the worksheet in the dashboard as a filtering option. How to do that? Come back to the dashboard sheet, dashboard 1. Click on any visualization of your choice up to your this thing. So I'm selecting the deposit buyer by month sheet, and I'll try to use this as my filtering worksheet. So here you can see when I clicked on use as a filter. If you just go here, you can get use as filter drop down. When you click on any visualization in your dashboard participants, that is when you highlight, on the right side, you notice you're given 4 options: remove worksheet, go to sheet, use as a filter, and more option. That's what I'm talking about. I am selecting the second worksheet and using it as a filter for my dashboard. Now you can see the funnel icon activated when I click on filter. What does this mean? When we move our slider, notice its impact on the first sheet also, right? So this is all about your dashboard, connecting 2 or more worksheets, adding elements like sliders, drop downs by customizing, establishing interactivity between worksheets, which of your interest. Then go to the presentation view finally, click on presentation mode F7. Can you all see my final dashboard with the elements in the dashboard, right? So let's play with the dashboard. Initially all days of week and all months. Now I'm moving my slider March month. Check out in the March month, all days. In the March month participants, what is the response rate of the depositor on all days? More or less in March month, all days, majority of the people are saying yes and no, right? Okay. Then let's tune the day of the week. Let's take Monday. Now look at Monday. In March month, on Monday, majority of the people are saying what? Look at the tuned dashboard. Majority of the customers when contacted on Monday in March are saying no. So Monday is not the appropriate day in the month of March. So let's check other days. Click on Tuesday. Now the scene changed on Tuesday in the month of March participants. When I'm moving the slider element in the dashboard, Tuesday in the month of March, what happened? Check out. Majority of the customers on Tuesday in the month of March are responding yes. This is the power of Tableau's dashboard, a real visual grandeur for you all. Because if such a business intelligence dashboard is developed and shared to the banking, don't you think that will give a lot of value to the bank? What do you say, participants? Will it add a lot of value or not? Yes or no? Lot of insights can be gained, right? Yes. Now let's go for Wednesday in the month of March. Wednesday, more people are likely to say yes. Let's say Thursday in the slider. Now the scene changed. When I choose Thursday in the month of March participants, what happened to the response rates? Unlike Wednesday and Tuesday, on Thursday in the month of March, majority of the customers are saying no. Let's look on Friday finally. Now it's Friday, weekend. What is happening to the response rate? Again, more buyers are likely to say yes. Likewise, you can study the patterns for April, May, June, so on, so forth, right? So typically, this is the art and science of converting raw data of a business into a real professional visual business intelligence, giving insights. Tomorrow, I will add more light on how to share this BI presentation using Tableau Public to a global world of community users in a business organization. Is it clear, participants? Everybody? Yes, Krishna Teja. It is possible to create animations at the dashboard. That's what I created. Interactive dashboards, elements like sliders, drop downs, push buttons, everything, animations can be added, and you can connect worksheets. Most important one, how I added worksheets as asked by Bhargava. I am showing it again because that is the most typical success story where most of you might face the difficulty, trouble. Once again, for the benefit of participants, I am showing the real appeal of connecting the dashboards. So after pulling the best days for marketing and deposit buyers by month, both into the dashboard to make them interactive. What is meant by interactive? Showing the mutual effect of one visualization over the other. What we did, I went through the best days for marketing sheet. I hope all of you can see the best days for marketing sheet once again, right? In the best days, what is the filtering item? Days of week is a filtering item. So you can see actually month was not there, but when I connected to the sheet, month appeared here. How did I connect? Click on days of week filter, go to apply to worksheets and go to selected worksheets. In the selected worksheet, make sure as an analyst, when you change the day slider, when you change the slider day of the week, it should show impact on month also. So select the sheet named deposit buyers by month or any worksheet of your choice which is currently active in the dashboard. Select that sheet and click OK. Similarly, in the worksheet named deposit buyers by month, in the worksheet named deposit buyers by month, what is the filtering slider? Month is the filtering item. So click on month drop down and choose the command apply to worksheets and choose selected worksheets, right? This selected worksheet, if you click on, it is asking how you want me to become interactive. Which worksheet should I affect? Best days for marketing is the dependent sheet. Month should be connected to best days. That's why I selected best days for marketing. Click OK. If you want, you can connect to other sheets, but make sure those sheets are pulled into the dashboard for a better view. This is the method of connecting, interconnecting the pivot graphs, pivot charts. Technically, Tableau calls these charts as pivot charts because they're rearranged data visualizations. Connect these pivot charts, go to your dashboard, and then pull over your visualizations that you have done so far, and then you can add graphical elements, sliders, drop downs, pull down buttons, command clickable buttons, check marks, anything. Graphical animations can be added. Finally, go to the presentation view. To go to the presentation view, you have here the presentation mode. On your toolbar, you can press your F7 key, okay, or you can simply click on the presentation mode, will take you to the presentation mode here. This is in the presentation mode. You can see an individual visualization or you can see a complete comprehensive dashboard with animations, right? This is how you can present, but that's not the end of game, dear participants. This is how the journey of raw data to a corporate BI dashboard took place. Tomorrow's session, the last one, I'll show you how you can actually present this graphical dashboard, interactive dashboard, to a community of your colleagues using a Tableau product called Tableau Public. For that, you all have to register on public.tableau.com, register your Gmail, your email ID and password. Then you will connect your dashboard to the Tableau Public and create your own digital visual profile online. That will be done tomorrow, right? Now, let me ask you all, give you some space of relaxation for questions before I just brief the outline of second case study and then end the day. Any questions? Storytelling will be doing tomorrow, Dinesh. Storytelling will be doing tomorrow. Once you all people get accustomed, enough practice with dashboard, storytelling is very easy. Storytelling is pulling the worksheets and writing some articulation to give you meaning to it. Modeling, we will be checking out the time tomorrow. If time permits, I will demonstrate one cluster modeling based on the time permission. But the actual coursework is limited to only to visualizations with dashboards and story writing only. Yes, Deepesh, you need to sign up on Tableau Public. If you're interested, you can do, or at the end of the session also, you can do it. Tomorrow, however, I'm going to show how to sign up on Tableau Public, but I would appreciate participants who want to sign up on Tableau Public. Just open a browser URL, open a browser and type there public.tableau.com. It's very simple. Public.tableau.com is the way to register your profile on Tableau Public. Onkar, the technical difference between a bin and a group is bin technically represents a group, but statistically bin is a inherent collection of data properties of similar nature, or more or less it is a representative interval of the data, while group is the natural characteristic of the data, like how we have created the age group or the call duration group. Devarath, if the second worksheet is not fitting, don't worry. You can lay out the visualizations one below the other or one aside the other also. So I think yesterday you were trained by the mentor on how to resize your dashboard, right? Shivam has greatly trained you all on how to resize the dashboard. The size option is there on the desktop. But as I told, I will show you on the device preview for the information. The device preview. If you can click on device preview, participants, finally for today, you can see the device preview. Currently, when I click on device preview, you have been given with default device. When you click on drop down, what are the devices you're seeing? Desktop, tablet, and phone. Currently, this dashboard visualization was created on desktop. But if you want to see how it looks on a phone, just click on a phone. This is how the typical view of your dashboard when you share. If somebody opens it on a phone, this is how it looks like on a phone, smartphone or a mobile phone. And what is the model? Generic phone. But you have many models. Just click on drop down. You have iPhone X here. When you click on iPhone, this is how the dashboard looks like on iPhone X. This is on iPhone 7, how it looks on iPhone 7. When you click on it, enhances. When you click on a Samsung Galaxy Note series, look at how the view expands. When you share this visualization via Tableau public to your community, and if that community users open your dashboard on a mobile phone on different models, see how the visualization is appearing. If you open it on a Nexus series, this is how the visualization appears. This is the preview. How I got this? Just click on device preview here. The default is phone here. This is how. But if you are interested to see how the same visualization appears on tablet, your internet tablet, just choose the device type as tablet. Now look at the tablet view. Tablet is a landscape handheld device, while a mobile is portrait oriented device. That's why nature of the orientation also decides the view type. Now from generic tablet, if you want to switch on, if you want to go to a Samsung Galaxy tab, click on the model. When I click on the device preview, got device type, model name, and add tablet layout. So a Samsung Galaxy tab, if I add, this is how your dashboard looks on Samsung Galaxy. If you want to add this layout, participants, simply click on add tablet layout. Now you see, this is the tablet layout. This is the phone layout for your view. And this is the default layout for your visualizations. I mean, dashboard looks default on a desktop like this. On a Samsung Galaxy tab, it looks like this. On a Nexus mobile phone series, it looks like this. This is called device preview, or this is how you can manage your visualizations before sharing to the public community. You can get a preview of how these dashboards look on different devices, right? Now, the second practice case study, which we gave to you, called power plant. As you all know, nowadays from the power sector, many industries, manufacturing industries are manufacturing electrical energy power, and the electrical energy is produced from utilizing a lot of natural resources, such as your water, that is hydel, thermal, and your natural resources like your coal, which are available under earth resources. Similarly, many of the power plants, manufacturing sectors, I hope you all can see my presentation again. Is it visible, Shivam?
Yes, it's visible, Mr. Mohan.
Yes, great. The next case study is performance analysis of combined cycle power plant, where I'm going to give you only the knowledge transfer. You participants can take the privilege. Already the data sheet was shared, named power plant, connect it to Tableau, build visualizations and dashboard, and get insights from it. But for that, let me give you all the motivation why I'm giving this project to you all. In this project, second project, as a visual researcher or data analyst, your goal is you have to generate visualizations from parameters given in the data set. I will explain what parameters are. Parameters usually given are ambient temperature, atmospheric pressure, relative humidity, exhaust steam pressure, or technically this is called vacuum. Most power plants employ two types of turbines, namely steam turbine and gas turbine. Steam and gas turbine. When you plug in a natural resource like your water, pump it across turbine, these turbines rotate at high pressure and generate lot of heat temperature based on the atmospheric relative humidity and the vacuum. The energy is generated. Mechanical energy is converted into electrical energy to this process. For a briefing, let me show you all a quick video if possible in the time frame. Just wait for a couple of seconds and plugging in the video. Yes. Playing in the video. Yeah. I'm sharing the video here. Watch this architectural engineering of power plant. Can you all see my video screen? Shivam, is it visible first?
Yeah, is it visible?
Watch it, friends. Power plant.
Modern power plants generate terabytes of data, but they're not digital. Today, less than 2% of data is leveraged at all, isolating the plant and leaving the power business in the dark. To avoid unplanned outages, plants are forced into a conservative balance between operations and maintenance, costing billions in unseen value every year. But what if they didn't have to work? What if anomalies were predicted and maintenance was based on need, not the calendar? And what if you could redefine operations using advanced software to transform your entire power business? The digital power plant, powered by Predix, brings dark data into the light. Advanced software, analytics, and low-cost sensing converge with the industrial internet to reveal the hidden power of big data and seamlessly connect your entire energy portfolio. The digital power plant is designed to increase asset performance, enhance operations, and improve energy trading decisions to create additional revenue and cost reduction opportunities. When assets in the plant are connected, they provide the operator and dispatcher with visibility to how operations can influence smart business decisions to achieve greater efficiencies across the plant and fleet. This is a virtual copy of the power plant that lives in the digital world. Software analyzes sensor data, leverages predictive analytics, and simulates a limitless number of scenarios, laying them out in software to build the digital twin of your entire plant. The digital twin determines where and when specific assets will need maintenance. It takes into account the entire plant to determine the capacity to fulfill demand based on asset performance, operational efficiency, and changing market conditions. Now the trader and dispatcher see a much bigger picture, giving them the confidence to make calculated commitments to dispatching energy without unforeseen maintenance or wasted fuel. As the digital transformation expands across the energy ecosystem, shifts in demand and increased pressure from new generating technologies create exciting opportunities. With the ability to balance the load across the energy portfolio, sources like renewables, gas, and nuclear can all work together to bring power to the grid for a better business outcome and a better future. The Digital Power Plant by GE.
So if you notice, gone is the word of electrical power plants. Today is the world of digital power plants, is where the heights of analytics, business intelligence is transforming to, right? So if possible, let me just show you one typical video, final, then we'll close the session. Let me share this. Shivam, can you see the screen again, all participants?
Yeah, I think the video is lag and also the audio is not audible.
Yeah, now I'm playing it. I just paused it wantedly. Now I'm playing it. Understand this video, participants. The same project data was given to you for your practical experience.
The The Siemens Flex plant is a combined cycle facility. That means that it uses two steps of energy production, combining two different energy producing cycles. In the first step, electricity is produced using a gas turbine. It operates much like an aircraft's jet engine. However, the gas turbine in this configuration supplies power from its spinning shaft directly to its generator to make electricity. Air is compressed in the gas turbine through multiple precision fan blades. This compressed air is mixed with natural gas, then ignited into a stream of high-energy, high-pressure air. The power of the pressure and extreme heat passes through a set of turbine fan blades, which spin the turbine shaft at 3,600 RPM for 60 Hz markets or 3,000 RPM for 50 Hz markets. The spinning shaft of the gas turbine is attached to an electrical generator, which converts this energy into enough electricity to provide a small city with all of its electricity needs. As the exhaust exits the gas turbine, it still has plenty of energy to utilize. This energy is used to power the second step of the flex cycle process. The excess heat of the gas turbine is routed to specially designed
don't put on the chat, it will abrupt the video. Stop chatting,
exhaust flows past
then you can see the video correctly.
filled with water, causing the water to boil and convert to steam. The steam is then routed to a steam turbine that is also connected to a generator, making even more electricity. The steam turbine is powered completely by leftover heat from the gas turbine's exhaust, which makes this combined cycle highly energy efficient, using less fuel for more power. Every of the flex plant combined cycle process is focused on efficiency, minimal environmental impact, and lower CO2 emissions compared to traditional fossil fuel power plants. This process is very efficient. But how is its electricity actually created? The massive gas and steam turbine horsepower is used to spin the generator shafts, which convert the rotational energy into electricity. The shafts inside the electrical generators consist of a series of electromagnetic copper coils, which rotate within a casing lined with additional coils. The magnetic field of the rotating shaft coils excite the electrons and create a flow of electricity through the outer electromagnetic coils. This flow of electricity is directed to a transformer and distributed to the power grid. That's where a modern, intelligent, and reliable grid infrastructure is critical. Managing energy from various points of creation across distances to points of consumption, and balancing the needs of the consumers with the generation resources available in real time. As the opportunities for renewables expand, the need to provide alternative, consistent, on-demand power is critical. Whether it's the lack of sunshine, quiet winds, or an unexpected peak of energy consumption, Siemens Flex Plant is the efficient solution for consistent electricity production.
So hope so participants, you all could have a view on this kind of this thing, especially this power plant electrical digital engineering is more relevant for people who might, if any participants are from electrical engineering discipline in the current seminar, faculty members from electrical engineering, PhD pursuing, postdoc, looking for consulting activities. This is all a wonderful case study that you can actually look in. Data set actually was given to you, consists of the variables participants, as you all can see. Let me share the PPT again. Hope you all can see my PPT.
Yes, they are.
Yes, so it's a very small size data set. Temperature in degrees centigrade with minimum 1.81 degrees to max of 37 degree. Ambient pressure in a certain range measured in millibar. Relative humidity, exhaust vacuum, and the final output variable, target variable for this project is the net hourly output. Your role as a visual analyst in this project is connect this data set of power plant to Tableau, explore the relationships between all the input parameters like temperature, ambient pressure, relative humidity, vacuum against the output variable, that is energy output EP. As most of the data are numerical continuous, which type of graphical plots appeal here? Anybody? All data are numerical for information. They're not categorical, right? All are measures only, no dimensions. So you can start building your scatter plots. Mostly your scatter plots are very much useful here. Very good. And you can create groups and bins. From the given measures, you can create groups and bins like which I demonstrated today and build dimensions, then model the relationship. All you need to study is whether there is a linear or non-linear relationship between input variables and output, build the visualizations, put them in a dashboard. You can share this kind of energy monitoring predictive systems for power plants. Hope to see you all trying this kind of real-time research where you can apply what you learned on Tableau in all these days into industrial research or application oriented research for societal benefits so that you can really prove that you can leverage on operational IT. So that's all for today. In the time limit given, any further questions you can pose in the chat and a quick time left over. You can save your workbook, Jyoti. Thank you, Ashish. Thank you, Kajal. Thank you, each and every one of you.
Those who have any doubts, so just post the doubt in the chat box.
Yeah. Don't worry, there is tomorrow one more session left over to see more
Yes.
case studies, industry case studies, followed by the great challenge we are throwing at you, analysis of COVID patients, the current scenario with Tableau, and sharing them on the community.
So yeah, thank you, Mr. Mohan sir, for delivered such a wonderful session.
Yeah.
It was a pleasure to have you with us. Thank you all for attending. We hope you have learned and enjoyed this session.
Yes.
So,
Thank you, Team
just you know,
SmartBridge. Thank you, each and every one of you.
thank
Take
you, sir.
care. Good night. Signing off. We'll meet tomorrow at same time.
Okay. Thank you, guys. Thank you. Thank you, sir. Now we end the session. Vanuka already provide the feedback link. So again, I just put up into the chat box. So you guys please provide the feedback. Protection. The data set is already shared with you guys for the PowerPoint. Okay, guys. So just bind up the session. Hope all of you understand. Thank you and all the best, guys. Thank you.